What if the Earth kept its oldest secrets not in stone temples or buried cities, but under a sleeping ocean of ice, so deep, so ancient, that the usual measures of memory no longer apply? What if the white continent at the bottom of the world were less an empty waste and more an archive? An archive so thorough that it had the power to erase entire chapters of planetary history from sight? This is the question that hangs over the first part of the story, the forgotten white continent. Part 1. The forgotten white continent. When the word Antarctica is spoken, it tends to conjure a single image, vast, bright, and indifferent. But the continent resists any single image. It is a palimpsest, an enormous, cold manuscript written in layers of snow and ice, and then written over again and again. The idea that something might be sleeping beneath those layers, that beneath kilometers of frozen history there might be traces of a time, a climate, or even an intelligence that modern eyes hardly imagine, grips because it forces a change in perspective. It shrinks humanity and the span of recorded history into an instant, set against the slow geological breath of a planet that forgets and remembers on different scales. The scale of forgetting is itself difficult to feel. To hold it, the narrator shifts the listener's sense of time. A single centimeter of Antarctic ice can be 100 years of snowfall. A borehole that disappears beyond the range of a human voice represents hundreds of thousands, even millions of years. In that register, a human lifetime becomes a single exhalation. A recorded year is a fleck of dust on a glacier. The continent's apparent emptiness is really a different kind of fullness, an accumulation of climate, of dust and gas and microbe, a silent ledger of atmospheres and seasons, no living memory traces. There is an uneasy intimacy to this forgetting. The ice is not passive. It is a slow, relentless hand that scours and buries. Where water once lapped at rocky shores, ice later piled high, crushing and cementing what lay beneath into conditions hostile to casual discovery. Organic material can be preserved in this way, delicate fragments entombed like insects in amber, but the same processes also destroy. Erosion, shifting ice streams, pressure, and heat deform and mix layers, smearing records across time like a smear on glass. The deeper and older the layer, the more likely it has been altered. The continent's forgetfulness has both preserved and concealed. The emotional tenor of this discovery is complicated. There is, first, a visceral awe at the idea of an archive that dwarfs human history. That awe is layered with a loneliness. Here is a place where the Earth's story is written in slow ink and the attentive reader is far from home. There is also a prickling fear, soft and rational, about the unknown. People imagine lost things with unwarranted tenderness, an expectation that something will be beautiful, meaningful, or familiar. The scientific imagination, however, must balance that tenderness with skepticism. The very processes that permit preservation also select for certain types of survival. Bones, built structures, and ephemeral records fare poorly under ice and tectonic action over deep time. Chemical traces, isotope ratios, and subtle anomalies in magnetic and gravitational fields are more likely to survive than a carved monument. The emotional response, then, is a layered one, a mixture of hope, caution, and the humility that comes from realizing how quickly everything human can be folded into geological time. That humility is necessary. It forces a different kind of curiosity, less about treasures and more about patterns. It asks, for example, what the ice itself can reveal about time scales beyond human comprehension. Ice cores become the protagonist of this inquiry. Each core is a vertical strip of time, a concatenation of winters and summers, dust and ash from distant volcanoes, pollen from ancient pollenscapes, and microscopic life that persisted in niches now forbidding. When scientists tilt a cylinder of ice against the light and begin to read its banding, they are, in a sense, listens for the whisper of ages. They listen for warmth that came and went, for atmospheres that rose and fell, for signals of sudden change that might hint at collapses or transformations, human or otherwise. There is a strong narrative temptation to turn these natural records into clues of vanished civilizations, the dream that beneath the ice lie streets and cities fossilized in permafrost, like instant cities frozen mid-breath. That temptation is part of a larger human appetite for continuity, a desire to find ourselves in the past, to trace a lineage of thought and artifact that reaches back unbroken. The speculative documentary voice must acknowledge this desire honestly. It must also remind that continuity is fragile and often illusory at deep time scales. Civilizations, as modern humans define them, are ephemeral. They leave marks, stonework, metallurgy, language, but over the course of millions of years, tectonic forces, glaciation, and chemical weathering can obliterate those marks. The question, then, becomes not whether ancient humans could have existed, but what kinds of traces would logically survive and where to look for them. The narrator invites the listener to imagine the continent's underside as a geography of relics, subglacial lakes, buried river networks, bedrock that bears the scars of other climates, and deposits of organic material locked away from oxygen and decay. There are places like Lake Vostok, isolated water bodies under miles of ice that might have been ecologically isolated for millions of years. If life persisted in such environments, it likely did so in microbial forms, adapting to cold, pressure, and perpetual darkness. These microbes, if analyzed, could tell of metabolic pathways adapted to extremes, offering hints of life's versatility. They could also carry chemical fingerprints that speak to atmospheric compositions of the distant past, to episodes of warmth and warmth's retreat. And yet, the documentary voice also draws a line. The presence of microbial life or of ancient organic residues is not the same as the presence of a civilization. Civilization, as a concept, implies systems, technology, social complexity, material culture that modifies landscapes in discernible, enduring ways. Over deep time, those signs, stone walls, roads, metal implements, are subject to dissolution. Even metal corrodes, buildings collapse, and cultural patterns leave only partial traces. The narrator argues that if a sophisticated civilization existed on Earth millions of years ago, the most reliable remaining evidence would be in the geochemical and isotopic anomalies they left in sediments, anomalous concentrations of rare elements, traces of synthetic compounds that do not occur naturally, or sudden shifts in carbon isotopic ratios inconsistent with natural cycles. These are the kinds of clues that contemporary scientific instruments are designed to detect. Remote sensing, ice-penetrating radar, seismic tomography, and satellite gravimetry allow researchers to peer beneath the ice without disturbing the environment. When a radar beam returns an echo from the subglacial realm, it is not a melodramatic reveal, but a data point. A reflection coefficient, a thickness estimate, a potential clue to a buried valley or a water body. It takes interpretation, imaginative, rigorous, and careful, to transform that data into a narrative. The possibility of misreading signals is ever present. A man-made object and a basalt outcrop can look similar at certain wavelengths. Human imagination can make a city where there is only a mountain range. Good science short circuits that inclination with cross-validation and constraint. Antarctica's forgetfulness is not uniform, however. Certain contexts favor the survival of unusual signals. Sedimentary basins, for example, can accumulate and preserve matter over long periods, and a anoxic environment can slow decay dramatically. Similarly, chemical pathways in deep, cold lakes might preserve lipid biomarkers that are distinct from natural geologic background. If the narrator imagines a spectrum of survivability, it runs from ephemeral to persistent, decorations and ephemeral art at one end, isotopic anomalies and stable mineral assemblages at the other. The careful listener is reminded that discovery is statistical and circumstantial. What survives is rarely the most glamorous artifact. It is usually the simplest chemical signature or the most robust mineralogical anomaly. This leads to a second emotional register, the slow burning thrill of detection. It is not the kind of thrill born of cinematic discovery. It is quieter, cumulative, and more precise. It arrives when multiple independent lines of evidence begin to intersect. A radar anomaly aligned with an unusual sedimentary sequence revealed by seismic reflection, an unusual concentration of a synthetic molecule in a core sample that correlates with an isotopic excursion, a magnetic anomaly that fits a subsurface geometry. Each match pricks the scientific imagination like a distant star appearing in a dark sky. The cumulative effect is a different kind of story than adventure fiction. It is the story of how the world reveals itself in layers, and how patient methods and modest tools assemble a coherent picture from fragments. At the same time, the narrator insists on restraint in extrapolation. There is a philosophical humility here. The Earth is not a puzzle designed to be conclusively solved on human terms. It contains contingencies and chaos. Long-term processes are not always reversible in the kind of tidy narratives humans prefer. Missing pieces do not necessarily imply deliberate erasure or mystery. They may simply be the consequence of processes that operate at scales indifferent to meaning. The forgotten white continent thus becomes a mirror for human finitude. Standing metaphorically at the edge of this frozen archive, humanity confronts a reality that both diminishes and enlarges it, diminishing. Because the human story is a narrow filament in the deep fabric of planetary time. Enlarging because, if anything at all has endurance, a chemical anomaly, a microbe adapted to the cold, a shifted ratio of isotopes, then those remnants are shared with organisms that will endure long after human memory has faded. The narrative voice is careful not to sentimentalize this. It frames the discovery of deep time traces as an invitation to humility and curiosity rather than as confirmation of human centrality. The first segment closes on a thought image, the continent as a sleeping library, dust motes of ancient atmospheres drifting through its stacks. The idea of civilization in such a place is not discarded outright. It is considered as a possibility constrained by physics, chemistry, and the stubborn arithmetic of deep time. The story will continue, the narrator promises, into the specifics of what the continent hides, how science listens, and what it would mean to find more than echoes. For now, the listener is left with the sensation of standing before a closed door, of sensing warmth beyond it, but not yet possessing the key. Part 2. Antarctica K. The concise title is almost like a cipher, Antarctica K. The letter is small, enigmatic. It can be read as a symbol for the unknown, like the constant K in an equation. A, hidden. Parameter that modulates a system's behavior. In this case, K is the set of variables that decides whether anything meaningful could have persisted under the ice, rates of burial, geological stability, chemical alteration, and the resilience of various materials. To unfold the meaning of Antarctica K is to unpack those variables and imagine the geometry of possibility. First among those variables is time itself, the age of the ice, the cadence of glacial cycles, and the timing of any hypothetical occupation. Antarctica has not been uniformly glaciated for the same length of time. The continent has undergone dramatic changes. There were epochs when its climate was warmer and forested, and times when the ice was more extensive. These shifts are not just curiosities. They determine windows of opportunity. A hypothetical coastal habitation, for instance, would have been most plausible during interglacial periods when ice retreated and sea levels fluctuated. But coastal does not guarantee preservation. Coastlines are dynamic. Storms, tides, and later glacial advances can rework them entirely. Another variable is geology. The bedrock topography under Antarctica is varied. There are mountain ranges buried under ice, subglacial valleys that once carried meltwater and sediments, and basins that could have trapped organic-rich deposits. Sediments in these basins could record episodes of warmth, terrestrial vegetation, and even anthropogenic activity. If it occurred, the preservation potential in such settings is higher than on exposed bedrock. Yet even in basins, the passage of millions of years can alter the chemistry of sediments, leach away organics, and transform mineral matrices. For the speculative documentary voice, this is not discouraging so much as it is grounding. It turns romantic hypotheses into testable propositions. It shifts wonder toward method. The chemistry of burial, the interplay of oxygen, microbial activity, pH, and pressure is another crucial factor. An anoxic, cold environment can dramatically slow decay. The narrator points out how bogs on other continents preserve organic matter for millennia, wooden structures, textiles, and even human remains. In the Antarctic context, buried sediments sealed beneath ice could act as natural cryopreservation chambers. Lipid biomarkers, resistant organic molecules, and certain isotopic ratios are survivors in such contexts. If a past event injected synthetic compounds into the environment, compounds that do not readily form through natural processes, those could persist as unmistakable fingerprints. The fourth variable is the outlines of human-like activity itself. What would a prehistorical technological signature actually look like after millions of years? The documentary explores scenarios. One scenario posits that advanced metallurgy would leave trace element anomalies, nickel, chromium, platinum group metals in unusual concentrations. Another posits the presence of long-lived isotopes from nuclear activity, while speculative nuclear signatures are exacting and, if present, incontrovertible. A third scenario considers large-scale landscape modification, canals, terracing, or megastructures, and what they might leave in the morphology of sediments. The narrator stresses that each of these would not be obvious from the surface, but they could be detectable through integrated geophysical surveys paired with careful sediment analysis. Antarctic also incorporates the dynamic of discovery, the tools, the patience, and the ethical constraints. To reach the deepest, coldest layers is to perturb a sensitive environment. The scientific community debates not just how to drill and sample responsibly, but whether humanity should disturb isolated ecosystems at all. A speculative discovery would therefore be mediated not only by geology and chemistry, but also by ethics and international governance. The narrator uses this reality to temper the thrill of discovery with a reminder of stewardship, the knowledge that some doors, once opened, cannot be closed. Ultimately, the K stands as an emblem of possibility governed by rigorous limits. It is the ratio of imagination to skepticism that will determine the next steps of inquiry. If the boundary conditions are plausible, if stratigraphy, chemical markers, and geophysical anomalies line up, then the search moves from speculative fiction into a disciplined quest. If they do not, the continent remains what it has been, a vast, eloquent silence whose primary gift is the lesson in scale. The section ends with a quiet invitation rather than a climax. The narrator asks listeners to hold two truths at once: that the forgotten white continent is capable of preserving some fragments of the ancient world, and that much of congealed history has been lost to processes that are as indifferent as time. The intrigue does not require a cinematic reveal. The deeper fascination derives from the slow, methodical work of science and the uncanny sense that Earth's oldest stories might be hiding in plain sight, encoded in ice, sediment, and the physics of a planet that keeps its deepest secrets folded into its crust. In this way, the story of Antarctica is not just geographic, it is philosophical. It confronts the listener with a question that will echo through the subsequent parts. How should humanity read the planet's long, layered script? The answer will require patience, humility, and an understanding that the most profound discoveries often arrive not as triumphs over mystery, but as small, steady clarifications. A chemical anomaly here, a radar echo there, that, when stitched together, illuminate more than any single artifact might. The continent, in its cold indifference, becomes a teacher of time. The listener is left suspended at the threshold of discovery, summoned forward not by spectacle, but by the deep, slow insistence of questions that demand waiting. What does it mean to say that Antarctica was not always cold? It is not a description of weather so much as a question that rearranges the listener's sense of possibility. To imagine the Antarctic of deep time is to imagine the geography of opposites, a place of polar light and temperate warmth, of forests succumbing to glaciers, of rivers that once braided across loam, now crushed beneath kilometer-thick ice. The phrase, "not always cold," opens a doorway. On the far side of that doorway lies a layered archive, rocks, fossils, chemical signatures, that quietly records climates and ecosystems that modern eyes find almost impossible to reconcile with the white continent they know. If the story of Antarctica were a book, the chapters written 100 million years ago would read like something out of another planet. During parts of the Cretaceous, greenhouse conditions on Earth raised global temperatures, sea levels were higher, atmospheric carbon was greater, and polar regions experienced winters of darkness and summers of prolonged light, but not the frozen void of today. In those intervals, forests grew near the poles, plants rooted into soil, insect and vertebrate life moved in seasonal rhythms, dinosaurs wandered landscapes of rivers and deltas. This is not speculation in the poetic sense, but an inference grounded in multiple, independent lines of evidence, three broad classes of proof that scientists return to again and again when reconstructing deep climates. The first line of evidence is macroscopic, the fossils themselves. When geologists and paleobotanists pry at the right layers, they find the remains of plants and animals no longer expected at polar latitudes. Fossilized wood, leaf impressions, and the compressed seams of ancient peat and coal tell of landscapes where green once dominated. In some parts of the Antarctic Peninsula, and on isolated islands that once lay adjacent to the continent, beds of sediment preserve imprints of leaves and branches, and occasional bone fragments attest to vertebrate life. These remains are the most visceral sort of proof. They translate geologic time into objects the human imagination can grasp. A leaf imprint is a memory pressed into stone, a shape, a venation pattern, a hint of seasonality that a microscope and steady hand can read. But fossils demand context. A single leaf does not reconstruct a climate. It is only when those leaves are found within river deposits, when their orientation suggests transport by flowing water, when they occur alongside riparian sediments and paleosols, that a coherent picture emerges. The texture of the rock, the grain size, the orientation of laminations. These are the clues that allow scientists to say not merely that a plant lived here, but that it grew in soil near a stream under conditions that allowed trees to thrive. The scenes suggested by these deposits are ordinary in their detail: roots penetrating horizons, leaf litter building humus, insects nibbling. Ordinary because ecosystems, even those that now seem exotic, are made of recurring, mundane processes. The second line of evidence is microscopic, yet no less revealing: pollen, spores, and other paleomorphs preserved in sediment cores. Palynology, the science of fossil pollen, is an exercise in patient interpretation. Pollen grains are tiny, robust capsules of reproductive material. They resist decay and can survive for tens of millions of years. When sealed in the right matrix, a sediment core can be a palimpsest of past vegetation. Each layer of mud, each smear of organic rich sediment can be read like a census. The presence of pollen from plants now associated with temperate climates, ferns, conifers, and broadleaf families speaks less to whimsy and more to ecological composition. Palynological assemblages carry implicit information about seasonality and temperature because plant communities are tuned to climate. Reading pollen is an exercise in listening across an abyss of time. In a lab, with a microscope's light cutting the dim, a scientist can watch patterns emerge. A succession from forest-dominated pollen to a sudden influx of bryophyte and algal material, perhaps signaling a climate downturn or a marine transgression. The record is rarely tidy. The Antarctic story is one of interruptions, warm interludes punctured by cooling events, ice advances, the slow subsidence or uplift of crust. But the palynological record is persistent enough to show that warmth once visited, regions now locked in ice. The third line of evidence is chemical and isotopic, the kind of signature that requires instruments rather than intuition. Isotope ratios, particularly oxygen isotopes in carbonate shells or in the mineral fabric of sediments, carry the imprint of ancient temperatures. Carbon isotopes record biological productivity and shifts in global carbon reservoirs. When these ratios move in coherent ways across stratigraphy, they reveal epochs of greenhouse and icehouse conditions. Marine sediment cores, drilled from continental margins and abyssal plains, act as thermometers of their day. Changes in the isotopic composition of foraminifera shells, for instance, indicate ocean temperature and salinity, and by extension, global climate. Layers rich in organic carbon may indicate lush terrestrial productivity and low oxygen conditions at the time of deposition. Together, these three categories, macrofossils, palynology, and geochemistry, form a triangulation. Each has its weaknesses. Fossils can be reworked, pollen can be transported long distances, isotopic signals can be influenced by local factors. But when they align, the case becomes strong. A succession of leaf fossils in fluvial sandstone, a corresponding assemblage of temperate pollen in adjacent mudstones, and a concurrent isotopic excursion pointing to warmer ocean temperatures is not poetic conjecture, it is a multi-layered argument. This is the science of evidence and the source of the story's emotional tone. There is wonder, of course, the surreal image of a forest at polar twilight, but the wonder is braided with a more complex affect, a sense of irretrievable loss and a keen humility. The planet writes and rewrites itself. Ecosystems that required a handful of favorable parameters for millions of years can be erased by a shift in one variable. It is both consoling and disquieting to think that the Earth has been home to so many different arrangements of life, and yet so little of that history persists in forms human culture would call monumental. These lines of evidence also have bearing on a different kind of question. What would survivals of any past intelligence look like? If Antarctica was temperate enough to support complex ecosystems 100 million years ago, did it ever harbor systems of organization or technology that could leave enduring traces? The narrative cannot long avoid the speculative edge of this thought. It must confront it with the same triage of evidence that guided the climatic story. Here, too, preservation potential governs plausibility. Macroscopic artifacts, structures, tools, art are fragile at geological scales. Even a stone wall, impressive in the short term, succumbs to weathering, burial, and tectonic reworking over millions of years. Yet not everything erodes evenly. Certain materials and signatures persist. Metals corrode, but can leave geochemical anomalies. Elevated concentrations of transition metals and sediment horizons, unexpected alloys trapped in anoxic beds, or localized enrichments of platinum group elements. Synthetic molecules, if produced in sufficient quantity and resistant to natural degradation, could survive as molecular fossils, chemical oddities in sedimentary records that do not match known biogeochemical pathways. Nuclear isotopes, if introduced into the environment, pose a particularly distinct signature. Certain isotopes have half-lives that render their ratios anomalous beyond natural backgrounds and thus detectable given precise measurement. This is not to encourage cinematic fantasies of frozen cities revealed in radar scans. It is to state plainly what would be detectable across deep time, robust geochemical peculiarities, isotopic anomalies. persistent molecular structures and morphological changes in sedimentary regimes that lack natural explanation. These are the sorts of traces that belong on the checklist of a disciplined inquiry. They are the sorts of things that, when found by multiple independent methods, force a re-evaluation of assumptions. They are neither proof of romance nor of ruin. They are data, stubborn and reticent. The preservation story is also context-dependent. Certain depositional environments act as time capsules, anoxic basins, fluvial cutoffs rapidly buried by sediment, peat bogs sealed beneath later deposits. In Antarctica, the most promising contexts are river and lacustrine beds that were later buried by glacial till or subsumed beneath ice streams. Subglacial basins that trap organic-rich sediments beneath a shield of ice and rock may isolate chemical signatures from oxidation and biological colonization. And yet, even in these protected settings, diagenesis, the suite of chemical and physical changes that affect sediments over geological time, modifies, redistributes, and sometimes obliterates the original signals. The K of Antarctica, the set of variables that control preservation, thus includes time, burial rate, chemistry, tectonic stability, and the idiosyncrasies of diagenesis. There is a human side to this science that complicates the purely technical account. To look for deep time evidence in Antarctica is to confront ethical and logistical dilemmas. Drilling into a comparably pristine subglacial lake, for instance, risks contaminating an isolated ecosystem. The international agreements that govern Antarctic research embody a cautious ethic. The privilege of discovery must be tempered by stewardship. In practical terms, that means many of the most tantalizing archives will be approached with incremental, non-invasive methods first. Radar, seismic reflection, satellite gravimetry before any coring begins. The scientific community accepts that sometimes the most responsible decision is to let certain pages remain closed. This restraint does not diminish the narrative's charge. It deepens it. There is drama in patient accumulation, in radar returns aligning with sedimentary basins, in a seismic profile that reveals an anomalous layering of silts and peats, where ice age tills would more usually dominate, in a single sediment core that contains a pulse of odd molecules or a previously unseen isotopic excursion. The thrill here is epistemic, an appreciation of how small, careful observations combine to overturn assumptions. It is a different kind of suspense, one based on method rather than spectacle. So the record of a warmer Antarctica rests on modest things, leaf impressions, pollen grains, the chemistry of shells, the layering of river mud. Those modest things, when read together, tell a story of seasons, of forests under polar light, of rivers and lakes that hosted thriving ecologies. They also frame the limits of what can be known. The deep past is not a stage that preserves human-scale drama. It is a ledger that remembers processes more readily than persons. If intelligence or technology ever arose in those ancient forests, its traces would most likely appear not as frozen monuments, but as chemical perturbations in sediments, as isotopic oddities, as concentrations of elements that do not fit natural cycles. The listener is left with a dual impression, a sense of recovered richness, that Antarctica once bore life and unexpected abundance, and a profound humility about evidence and survival. The continent's archives are incomplete by necessity. They favor some kinds of memory over others, but within those preserved fragments lies the capacity to rewrite certain chapters of Earth's story. Each new core, each radar profile, each isotopic analysis is an invitation to rethink the scale and texture of the planet's biographies. Thus the phrase, "not always cold," is both a factual claim and an ethical prompt. It asks the listener to imagine a different past and to commit to careful inquiry in the present. It reframes the frozen continent not as a static monument, but as a dynamic archive constrained by chemistry and physics and mediated by human curiosity and restraint. The next steps of the story will follow those constraints, searching for the clearest signatures, evaluating the plausibility of extraordinary claims, and learning to read the Earth's slow handwriting with patience and an honesty that resists wishful reading. For now, the warmth of past Antarctic summers remains a testament to planetary change, and a reminder that the most surprising chapters of Earth's history are often written in the most ordinary ink. What if a single grain of pollen, a strip of petrified wood, and the echo of a radio wave returning from beneath a kilometer of ice were read together as sentences in a lost language? What would that language say? This is not a cinematic conceit, but a working hypothesis. Fragments, when assembled thoughtfully, can articulate a story that no single fragment could tell alone. In the frozen archive of Antarctica, Ice cores and fossils deliver the first words. Radar, sent through the ice, returns the punctuation marks. Together they begin to hint at chapters of the planet's history that are at once intimate and vast. From ice cores and fossils, at the scale of deep time, the smallest relics often carry the clearest information. A pollen grain is not merely a remnant of plant reproduction, it is a durable capsule of climate memory. Under the microscope, its sculpted surface and subtle morphological markers point to families and genera that belong to ecological communities of warmth, moisture, and seasonality. When a sequence of such grains accumulates in a stratified core, they read like a directory of past forests, ferns, and conifers, broad-leaved trees and marsh plants, shifting in abundance in millennia past. Each change in that directory encodes a response to temperature, precipitation, and daylight patterns that may have been radically different from today. Petrified wood adds a tactile dimension. Logs preserved in silicified stone cellular structures frozen in mineral tell of size, growth rings, and, crucially, of rhythm. Growth rings are calendars in slow motion. Their thickness and chemical composition indicate years of slow warmth or sudden chill, of plentiful rain or drought. A sequence of wide rings followed by a narrowing pattern speaks to an ecological transition. In the Antarctic record, fragments of wood and peat seams imply seasons where soil existed and where plant biomass accumulated. These are environments capable of sustaining complex food webs, including vertebrates. Reptile fossils, those brittle traces of bone, provide the third corroboration. Where bones and teeth survive, they anchor the floral record to animal life. Their morphology conveys ecological roles: herbivore, predator, semi-aquatic, and their depositional context reveals whether they live near rivers, lakes, or coastal fringes. A scatter of vertebrate remains in fluvial sands suggests living landscapes, not transient drifted debris. Such finds transform abstract inferences about climate into scenes: waterlogged soils, the hum of insects, the slow tooth of grazing animals. A continent, once written in green and brown, asserts its past abundance. But a story built on fossils alone would be incomplete. The real power of these finds comes in cross-lab corroboration. Palynology, sedimentology, paleobotany, and geochemistry converge. Radiometric dating of volcanic ash layers, brackets intervals. Stable isotope ratios from carbonate nodules and organic matter provide temperature proxies. Organic biomarkers, molecules derived from particular classes of organisms, survive where structural remains do not, offering biochemical fingerprints of past ecosystems. When these independent lines of evidence align, the conclusion is robust. Antarctica's present whiteness overlays episodes of temperate life and active hydrology. The emotional register of these discoveries is complicated. There is awe in picturing forests under polar light, a vividness born of juxtaposition, the image of long day summers and pale winters where today there is relentless cold. There is also a melancholic recognition of loss, the disappearance of entire ecologies to processes patient enough to dismantle them over millions of years. That melancholy is stitched to wonder not of human centrality, but of planetary variability. These relics remind that Earth's surface is a page constantly rewritten, that the scale of geological change dwarfs human time and narrative. The feeling is less triumphal than humbling, a sense that our species' memory is a brief flash against an archive that records climate and chemistry in slow, indifferent ink. And yet, even as cores and fossils sketch the past, there is a caveat hanging over interpretation. Preservation is selective. The sedimentary contexts that protect organic matter are rare and specific. They are basins, peat bogs, rapidly buried river channels, many environments that once supported life left little behind. The deeper, older the deposit, the more subjected it has been to diagenesis. The chemical and physical changes that rearrange, obscure, or erase signatures. A basalt intrusion, a tectonic uplift, a later flood of ice can scramble the strata. The task is one of probabilistic reading. Where will the evidence most likely have survived, and how to interpret what remains without overreaching? That probabilistic approach favors chemistry and isotopes as the most telling long-lived witnesses. Carbon isotope ratios can reveal abrupt shifts in carbon reservoirs. Certain synthetic molecules, if they ever existed in prehistory, would stand out as molecular fossils. These are the signatures that, if found, would be difficult to explain by ordinary biological activity. But finding them requires more than hope. It requires careful selection of promising depositional settings, minimally invasive sampling, and rigorous laboratory protocols that can distinguish diagenetic alteration from primary signal. The ice itself becomes part of this argument. Ice cores are vertical biographies of atmospheric composition. Layers trap dust, ash, microscopic fragments, and greenhouse gases. A centimeter of ice may represent centuries, a meter, millennia. Within those laminations lie pollen grains that have hitchhiked on winds, soot from fires, and even, in recent times, traces of industrial chemistry. Reading a core is an act of translation, deciphering the cadence of snowfall, the seasonal pulse of aerosols, the episodic bleeds of environmental change. Some cores contain macroscopic inclusions, leaf fragments, twigs, shards of wood, literal fragments of ecosystems that once breathed in warmer climates. A core that intersects an interval rich in temperate pollen, petrified lignin-derived compounds. An ochreous peat suggests an interplay of land and climate radically unlike what the present ice sheet implies. But even the cores are tip-of-the-iceberg narratives. For every pollen grain, there are hundreds of meters of ice that are silent. For every fossilized log, there are headwaters and deltas that left nothing. The archive is generous in some ways and miserly in others. The detective work, therefore, proceeds in degrees of confidence, from the modest and reproducible, a pollen assemblage dated in multiple cores, to the striking but ambiguous, a high reflectivity. Layer in radar that might denote either a sedimentary bed or a buried metallic mass. That last phrase, high reflectivity, brings the story to the next instrument in the modern toolkit, radar that penetrates ice. Radar through ice, suspicious structures. If fossils and cores are words and sentences, radar is the voice that announces the presence of chapters. Ice-penetrating radar, often called radial echo sounding, sends pulses of electromagnetic energy downward. Those pulses interact with dielectric contrasts, boundaries where properties such as permittivity and conductivity change. At an interface between cold ice and salty water, the reflection is loud. At a contact between ice and silty sediment, it is distinct in its own way. The returned echo is not an image in the popular sense. It is a profile, data points that must be stitched into maps. Yet those profiles reveal geometry, layering, and anomalous discontinuities that can look, at a glance, like signs that something unusual lies below. What qualifies as suspicious, in radar parlance, is more technical than cinematic, coherent. Localized echoes that depart from expected stratigraphy, reflectors that form regular, linear patterns rather than the undulating strata produced by ice flow, zones of diffuse scattering that suggest heterogeneity at scales smaller than the radar wavelength, or bright basal reflections variable on short spatial scales indicative of saline water, volcanic intrusions, or conductive materials. In a discipline accustomed to glacial rhythms, regularity is a provocation. Ice and geology often produce stochastic, chaotic signatures. When patterns emerge, parallel ridges, right-angled intersections, repeated spacing interpretation becomes urgent and cautious in equal measure. The most straightforward radar returns are those that indicate subglacial water. Liquid water beneath an ice sheet is reflective because its conductivity contrasts sharply with cold ice. Subglacial lakes, channels, and trapped water systems appear as bright basal traces. In some instances, these lakes align with sedimentary basins, plausible repositories for peat and organic-rich mud, where radar shows both a bright basal return and a horizontally continuous, stratified reflector above it. The inference is often a water-saturated sedimentary layer promising for preservation. Where radar traces show linear ridges of contrasting reflectivity, however, other hypotheses arise: bedrock ridges, eskers preserved as sedimentary ridges, or the imprint of long-ago fluvial systems now buried and frozen. More disquieting patterns to the human imagination are those that approximate geometry rectilinear discontinuities, repeated platforms or planar reflectors that suggest surface uniformity. But the Earth is adept at forging shapes that mimic design. Tectonic joints and fracture networks can create orthogonal patterns in bedrock. Subglacial erosion in the wake of ice streams can generate aligned grooves and megaripples. Sedimentary processes under certain hydrodynamic regimes lay down regular bed forms. Moreover, radar resolution is wavelength dependent. Features smaller than the radar's resolving power can appear as coherent scatterers, producing misleadingly geometric signatures. Conductivity matters. Radar that shows anomalously high reflectivity over short distances may be indicating a highly conductive substrate. Saline pockets, mineralized veins, or significant concentrations of metallic minerals can produce such reflections. In exceptional cases, a referee would demand secondary data, magnetic anomalies that would accompany ferromagnetic minerals, gravity contrasts that would accompany dense masses, seismic velocity changes that would corroborate differences in lithology. Only when multiple independent geophysical methods converge can anomalous radar echoes graduate from curiosity to plausible hypothesis. This convergence is the key to disciplined speculation. A radar anomaly aligned with a seismic reflector that shows a low velocity, high attenuation layer suggests water-saturated sediment rather than a solid metallic object. A coincident magnetic high would imply ferrous mineralization. Its absence would weigh away from an interpretation of metal concentrations. Geochemical signatures from nearby cores, elevated transition, metal concentrations, unusual isotopic ratios could tip the scales further. The methodology therefore demands integration. Radar proposes, other datasets dispose or confirm. The interpretative dance is also political and ethical. Deploying instruments over a promising anomaly is inexpensive. Drilling into a subglacial basin is not. The act of penetrating the ice and the sediments below carries risks of contamination for isolated ecosystems that may have endured for geological time. International protocols and ethical norms increasingly shape how such investigations proceed. Sampling strategies are staged, remote sensing first, then minimally invasive coring, and only then more disruptive operations if the scientific case and environmental safeguards justify it. That deliberative latter is itself part of the story, the scientific community's recognition that curiosity must be bounded by stewardship. Speculation inevitably surfaces in public reaction to unexplained radar features. The human inclination is to substitute completeness for caution, to fill gaps with narratives of lost cities or subterranean machines. The discipline tests such narratives with material expectations. An ancient technological complex, should it ever have existed and been buried beneath ice, would not likely persist as intact superstructures. Its most durable possible legacies are geochemical, unusual element, clusters, isotopic anomalies, synthetic molecular residues with exceptional longevity, or, in the unlikely scenario of nuclear activity, radiogenic, isotopic signatures distinct from natural baselines. Radar would at best identify targets for such geochemical assays. It would not, on its own, provide proof. The space between what radar can suggest and what coring can confirm is where both excitement and frustration dwell. A radar map might reveal a chain of linear anomalies stretching for kilometers across a subglacial plain. They might align with drainage channels visible in digital elevation models of bedrock, or they might not. A prudent program will follow with gravity surveys to detect mass contrasts, magnetics to search for mineral anomalies, and shallow coring to retrieve sediments for palynological and geochemical analysis. At each step, findings recalibrate the likelihoods. A consistent set of signs, sedimentary layers rich in terrestrial biomarkers, a pulse of unusual metal enrichment, and a stratigraphic horizon dated to a time when the region was ice-free would be a significant increment beyond mere curiosity. Even then, the narrative does not resolve into a single, comfortable tale. The deep past does not narrate with human clarity. Evidence remains probabilistic, interpretive, and often fragmentary. The mode of discovery in this domain is not detective drama, but patient accumulation. Each dataset is a modest addition to a ledger that gradually tips toward plausibility. The emotional tone that accompanies this kind of science is accordingly tempered. The thrill of a promising radar echo is real, but so is the humility of knowing how easy it is to read pattern into noise. The radar work also underscores an essential philosophical point about deep time inquiry. The planet's processes are neither conspiratorial nor benevolent. They are indifferent. Glacial scouring can erase cities as efficiently as it buries ash layers. Diagenesis can scramble a chemical signature beyond recognition. Permafrost thaw can mobilize and redistribute organics. Search strategies, therefore, privilege the most robust survivors. Chemical and isotopic anomalies, persistent mineralogical enrichments, and intact anoxic sedimentary traps. In that light, radar becomes a tool of triage, not a revelation engine, but a pointer toward the most promising pages in the archive. At the end of this section, the listener is left with a delicate tension, a catalogue of earthly traces, pollen, petrified wood, reptile fossils, that together establish a history of life and warmth, and the probing voice of radar that hints at structure beneath the ice, some ordinary, some disquieting, none yet conclusive. The drama is not that of a single discovery, but of an unfolding methodology. The continent yields clues slowly and according to its own rules. The human response is a mixture of fascination and restraint, of imaginative reach and conservative interpretation. The next chapters will follow the objects that radar points to, the sedimentary basins that could host chemical anomalies. the geophysical cross-checks that could confirm their unusualness, and the ethical frameworks that govern whether, when, and how to open these deep pages. For now, the image lingers of microscopic grains and mineral echoes combining into a narrative that both enlarges and humbles the human sense of history. The ice whispers, the instruments translate, humanity listens, learning to wait for answers that arrive in increments rather than in epiphanies. What does it mean when the instruments that watch the frozen world begin to hint at geometry, rows of straight edges, terraces repeated with uncanny regularity, a bright reflector that arranges itself into a form reminiscent of a foundation or a pyramid? The question itself is small and sharp. When a pattern appears where no human eye has stood for millions of years, how should it be read? Airborne radar and satellite-borne sensors have, in recent decades, transformed the invisible into the visible. They return long trains of numbers and waves, echoes shaped by permittivity, conductivity, and density. And from those echoes, technicians and scientists assemble maps. In certain surveys, those maps have shown things that look, at first glance, like built forms. Linear ridges align at right angles. Bulky triangular bulges rise from a flat bedrock plain. A sequence of bright basal reflections repeats at regular intervals, like courses of masonry. The shapes are sometimes described in shorthand, pyramids, walls, foundations, and the shorthand becomes the seed of a story. An Atlantis beneath ice. That shorthand is powerful because it answers an old human hunger. Myths of a lost southern continent have lived in culture for centuries. Plato's narrative of a vanished land beyond the pillars of Hercules is only the most famous iteration. The imagination has always wanted a stage on which the long-forgotten might be recovered. The discovery of regularity under ice reads like a line out of such myths. It is therefore worth pausing, not to dampen fascination, but to insist that fascination be met by methodical scrutiny. First, the instruments. What registers as a geometric form is rarely a photograph. Ice-penetrating radar sends pulses of radio waves through snow and ice. Those pulses return when they encounter contrasts, lodgements of water, sedimentary beds, layers with differing crystal fabric, or metallic concentrations. The signature of a bed of silty sediment differs from the signature of a basaltic ridge, a saline pocket reflects more strongly than compacted till. Satellite gravimeters sense subtle variations in the planet's pull, suggesting mass contrasts beneath the shield. Magnetometers measure anomalies in the magnetic field, which can indicate mineralization, volcanic intrusions, or altered bedrock. Altimeters measure subtle departures in the ice surface that betray the bumps and hollows of bedrock below. None of these alone paints a picture as clear as a daylight photograph. Instead, they speak in cross-checked suggestions. Geometry appears when several independent instruments converge on the same pattern. Even so, the conversion from signal to shape is an interpretive act. Signal processing filters raw echoes, applying gains and deconvolutions, applying imaging algorithms that sharpen edges. The human or algorithmic eye looks for coherence, a regular spacing, a repetition of angles, a linearity that resists the random. It is here, in the process of making sense of noise, that both insight and illusion can be born. Certain natural processes are adept at producing ordered patterns. Columnar jointing in volcanic flows, regular jointing in bedrock, polygonal permafrost features, and sedimentary bed forms shaped by steady currents can all yield lines and angles that suggest intentionality. Subglacial meltwater channels can leave straight, tunnel-like traces when they cut through bedrock along zones of weakness. Tectonic fractures often form orthogonal arrays. An alignment of regular ridges might simply follow a pre-existing set of joints in a buried ridge of basalt. In other words, the planet is capable of making geometry without intention. That fact does not collapse the possibility that some of the regularity could have a cultural origin. It simply reframes the problem. If a structure built by an intelligence existed beneath the ice, what would remain after the twin sieves of time and ice? The realistic answers are sobering. Stone walls can be rounded and recycled by chemical weathering. Mortar disappears in the absence of maintenance. Metals corrode, leach, and migrate. The survival of architecture across geological epochs requires either extreme luck in depositional context, rapid burial in anoxic, sediment-rich basins, or survival as an imprint in the chemical record. Thus, when satellite and radar suggest ordered forms, scientists immediately ask a battery of technical questions. Do gravity and magnetic surveys corroborate the inferred mass contrasts? Does seismic profiling show a layer of low velocity consistent with water-saturated sediments, or a discrete high-density body, consistent with compacted stone or metal? Dual cores retrieved from peripheral margins yield anomalous geochemical ratios, concentrated trace metals, synthetic molecules, or isotopic excursions that cannot be explained by natural processes. Part of the scientific response is procedural and painfully slow. The first reaction is rarely proclamation. It is, instead, the accumulation of cross-data sets. A radar reflector that looks like a platform must be checked against gravity for mass success. Magnetics must be scanned for mineralogical signatures. Seismic lines must test for continuity and layering. If the signals persist, the next step is targeted, minimally invasive coring to retrieve sediments that might hold organic biomarkers, metallic trace elements, or an isotopic fingerprint of unusual activity. Each step is an act of translation, transforming a pattern of echoes into a plausible history. There is another axis along which the discovery operates, the cultural appetite. Images of straight lines under ice spread rapidly. In an age when visual instantaneity meets ancient longing, the notion of pyramids under kilometers of ice becomes a media image as fast as a scientific hypothesis. The social response is a mix of wonder, hope, and a kind of territorial claim, making both intellectual and geopolitical. It is tempting to imagine that finding a city would recenter human history, to explain gaps in origin narratives, to make the world's past legible in a single spectacular tableau. Skepticism is not merely a scientific posture, it is an ethical one. To convert a remote, intractable grid of echoes into a claim about human prehistory without rigorous cross-validation would be to mislead both thought and policy. The hypothesis of a southern Atlantis is attractive precisely because it answers multiple anxieties and desires at once. It offers a lost source for human knowledge, a refuge for origin myths, and a dramatic counterpoint to the arrogance of an epoch that assumes itself as the first and the only. But for the planetary archive to have recorded a civilization in a way that is recoverable today, certain constraints must have been met. The occupation would have needed to occur in a window of relative warmth, an interglacial interval when coastal and lowland areas were not yet entombed. Those zones would have needed to be rapidly buried in an anoxic setting, peat bogs, lacustrine basins, or preserved beneath stable till that resisted permeation. The societal footprint would have needed to be substantial enough to produce chemical or isotopic signals of industrial processes, enriched concentrations of rare metals, persistent synthetic organics, or anomalous radiogenic isotopes. Otherwise, the signature would be dispersed into the geologic background. Another constraint is time and plate dynamics. Continental fragments and large-scale crustal movement can redistribute or destroy early records. Antarctica has not been a single static witness for Earth history. It has rotated, drifted, and been reshaped. A human-scale built environment has fewer ways to endure than an isotope ratio. Therefore, if anything of a cultural origin ever existed, the most plausible survivors are chemical. Anomalies in the distribution of rare elements, molecular fossils of synthetic compounds, or radiogenic isotopes that sit outside natural baselines. Those are the fingerprints that would raise eyebrows in a laboratory long after masonry had blurred into bedrock. There is also the hard limit of access. These hints of structure lie under ice that can be kilometers thick and under political protocols designed to prevent hasty intrusion. The Antarctic Treaty System, with its emphasis on environmental protection and scientific cooperation, places legal and ethical boundaries on sampling. The idea of punching through the ice with drills and mechanical cores is not simply a logistical hurdle, it is an ethical one. Many subglacial basins may host ecosystems isolated for geological time. To probe them without sterilization, protocols, risks, contamination. The community recognizes that some inquiries must be staged, incremental, and governed by a principle of restraint. The most tantalizing pages of the planet's archive may remain closed, not because they resist discovery, but because the act of opening could itself be destructive. This inaccessibility breeds a peculiar human psychology. The unknown becomes a canvas, and onto it are projected hopes, anxieties, and longings. The pattern-searching mind sees pyramids and organizes them into stories. The scientist sees an interesting anomaly and begins the slow, meticulous work of triage mapping, cross-sounding, sampling. The public and the specialist occupy overlapping but distinct emotional landscapes. Both feel awe, but the specialist's awe is braided with caution and a compulsion to test, or the public's awe can drift into certitude. There is a deeper emotional register at play here, not reducible to professional restraint or public sensationalism. The idea of an Atlantis beneath ice invokes a sense of smallness and mystery, the same feeling that moved earlier parts of the story, when the continent was portrayed as a sleeping library. To imagine entire systems of meaning entombed and ingloriously overwritten by glacial advance is to stand before the limits of human continuity. The feeling is not only melancholic, but existential. If such civilizations could arise and be erased, then human achievements, too, are part of a fragile chain. That realization reframes discovery as a moral exercise as much as it is an intellectual one. The impulse to know must be balanced with a commitment to preserve the integrity of what is left. At the same time, speculation has value. Hypotheses about a southern Atlantis catalyze technology, provoke interdisciplinary dialogue, and refine methods. The very act of considering extraordinary possibilities forces practitioners to sharpen what counts as evidence. It compels the development of better filters for signal processing, higher resolution geophysical surveys, more conservative coring techniques, and stricter protocols for data sharing. In that sense, the myth accelerates empirical rigor. The possibility becomes a tool for learning how to look. The most responsible path forward, then, is dual, to acknowledge wonder without abandoning method. When satellites and radar return echoes that suggest regular forms beneath ice, the next steps are not proclamation, but integration. Multiple geophysical datasets must be overlaid. Gravity and magnetics can test mass and mineral contrasts. Seismic lines can discriminate sedimentary layers from solid masses. Targeted coring can seek the chemical fingerprints that survive deep time. Each negative result is as informative as a positive one. The collapse of an architectural hypothesis in favor of a geological explanation tells a story about process. It reveals the planet's capacity to make order out of pressure, heat, and flow. There is also a forward-looking contingency to consider: climate change. Melting and retreat could, in the coming centuries, reveal bedrock terrains currently masked by ice, exposing morphologies and deposits for the first time in millions of years. That exposure may create opportunities for unprecedented research, but it will also be a moment of acute responsibility. The act of exposure can be destructive. Thawing peak can oxidize and disappear. Once locked, isotopic signatures can be diluted, and newly exposed landscapes become vulnerable to contamination. The world faces a paradox. Warming may make hidden archives accessible while simultaneously erasing the very context needed to interpret them. The hypothesis of a southern Atlantis thus becomes both a speculative scaffold and a cautionary tale. It provokes rigorous inquiry into how patterns under ice should be read, demands a careful accounting of preservation potential, and forces an ethical reflection on the costs of knowledge. Whether the bright reflectors and rectilinear echoes eventually resolve into basaltic fracture networks, depositional bed forms, or something more anomalous, the process of discovery will teach something indispensable about how humanity listens to the planet. In the end, the most honest posture is one that holds multiple things at once. It is to allow the image of a hidden architecture to inspire curiosity, while refusing the shortcut towards certainty without evidence. It is to recognize that the Earth keeps a ledger in many scripts: geometry and chemistry, echoes and isotopes, and that reading it requires patience, humility, and a readiness to be surprised in kinds that are not always comforting. The idea of Atlantis beneath ice may or may not find confirmation. What it already confirms is this: that humans long for deep continuity, and that science, when it is at its best, answers longing with disciplined awe. The instruments will keep listening, the maps will grow more detailed, and the threshold between suggestion and proof will be approached not with a single dramatic act, but with many small, careful steps. The continent below remains, for now, an eloquent unknown, its straight lines perhaps the product of molten rock, flowing water, or the slow artistry of pressure, and its secrets will be revealed, if at all, by the patient marriage of technology, ethics, and an imagination disciplined by evidence. But what if a fragment of hand-made parchment, scrawled by a navigator 5 centuries ago, could act like a hinge, swinging open a world of speculation about continents lost and frozen? That is the provocative image that centers the 6th part of this inquiry, the Piri Reis map, and the knot of questions it refuses to untie. The map is small, partial, and human, a piece of leather-bound vellum decorated with place names, coastline tracery, and notes that announce sources. Yet over the past century it has become something larger than itself, a mirror on which modern anxieties about deep time, suppressed histories, and the limits of human memory are reflected. The map's provenance is straightforward enough to catalogue. Drawn in 1513 by the Ottoman admiral and cartographer known as Piri Reis, the surviving fragment was attached to a larger atlas and rediscovered in the Topkapi Palace in the early 20th century. Piri annotated his work with pride, explaining in his own calligraphic marginalia that the map drew on a remarkable compilation. of older charts, Portuguese pilot books, Arab sources, and maps of the time of Alexander, a phrase that has only deepened the aura of mystery. For historians of cartography, the map is valuable mainly as a witness to the patchwork nature of early 16th century mapping, a collage of charts, compiled, averaged, and sketched into a new imperial register. But the map also did something else. To some readers, its southernmost coastline, where South America appears to stretch and curve into a broad southern landmass, resembles, with startling clarity to their eyes, the outline of the Antarctic coastline as would be recognized beneath today's ice. That resemblance, when coupled with Piri's claim of ancient sources, became the seed for an extraordinary hypothesis, that this small piece of Ottoman parchment preserves a memory of an ice-free Antarctic shore, implying that a sophisticated cartographic tradition reached farther back in time than conventional history allows. From that seed sprang a tree of theories. Physical scientists, historians, and popular writers began to debate whether the map was an index to an earlier world or simply a palimpsest of misunderstanding. The map's modern fame, therefore, rests on an interpretive hinge. One branch of interpretation is conservative and methodical. Piri Reis compiled coastal sketches from many sources, some of which derived from Portuguese and Iberian charts of newly encountered shores like Brazil and Tierra del Fuego. Misalignment of projections, errors in longitudinal reckoning, and imaginative filling of unknown spaces are endemic to early charts. Viewed in this light, the southern bulge is an extrapolation of South America's outline combined with speculative cartography. This reading cautions against leaping from resemblance to proof. Ink on vellum is not an ice core. It is a human product with its own conventions, blind spots, and aesthetic habits. The other branch of interpretation is more speculative and has been more resonant in popular imagination. It suggests that Piri's sources included genuine records from a very ancient seafaring culture, perhaps millennia older than the maps of Europe, capable of charting polar coastlines during a window of cosmically warm seas. Advocates of this view point to Piri's explicit list of sources and to the map's apparent geometric fidelity in certain stretches. As evidence that remnant charts survived into the early modern era, they ask a large, magnetizing question. If a civilization once mapped an Antarctic shore when it was free of ice, what does that imply about human antiquity, global navigation, and the erasure of whole cultural chapters by ice and time? The appeal of the latter is easy to understand. It marries two potent human longings, the desire for continuity, to trace a line from present knowledge back into deep prehistory, and the hunger for a dramatic answer to the visible absence in the geologic record. If ice can bury a city, might ancient charts be the last witness? The emotional charge is heavy: wonder, loss, defiance, or forgetfulness. Yet the cautionary voice must be equally audible. Cloth does not retain climates. A line on paper is not a measurement instrument. Piri Reis himself was candid about his methods. He stitched maps together from pre-existing navigational material, and he annotated where his information came from. When a historian reads those marginalia, the natural interpretation is not of extraordinary preservation, but of layered transmission. A chart describing a coastline could have been copied or reinterpreted many times before Piri drew it. Each copy would incorporate errors and the unavoidable distortions of projection. Projections, the mathematical rules that translate a curved Earth onto a flat surface, differ across cultures and eras. A coastline that appears to match Antarctica in one projection can be a distorted rendering of southern South America in another. The debate around the Piri Reis map is therefore instructive about how humans make evidence mean more than it strictly does. It reveals a cultural proclivity to transform ambiguity into narrative. To be clear, invoking the map in a search for long-buried civilizations is not merely a matter of romanticism, it is also a methodological challenge. If a map is to be considered as potential evidence for a pre-glacial Antarctic shoreline, it must meet stringent tests. Those tests range from cartographic forensic analysis, reconstructing the likely projections and sources Piri used, to rigorous geophysical correlation. Do the supposed mapped features correspond to isostatically adjusted paleo shorelines that the geology supports? Do sediment cores from the bedrock beneath the ice reveal the terrestrial deposits that a warm post-glacial coast would leave? Do geomorphological features consistent with ancient beaches and littoral deposits exist at the expected elevations when 1. accounts for glacio-isostatic rebound and sea level change? When those tests are applied, the reasonable picture grows more complex and less sensational. Paleogeographic reconstructions of Antarctica show that while some coastal sectors may have been relatively ice-free in deep time, During warm intervals, the timing, extent, and continuity of such open coasts vary greatly. Geological archives, shelf cores, submerged terraces, and benthic microfossils provide local and regional histories, but they do not uniformly support the notion of a mapped, ice-free Antarctic coastline persisting into the late Holocene in a way that an ancient chart could have captured. In other words, the physical terrain and the chronological windows required by the map-based hypothesis rarely align on the necessary scales. That mismatch is one reason why most glacial geologists remain skeptical of claims that Piri Reis charts pre-glacial Antarctica as a living shoreline. But scientific caution does not close the loop entirely. The map remains intriguing because it exemplifies the ambiguity of human sources for deep history. Human documents, maps, myths, lists of sources are themselves archives. They preserve traces of knowledge that may, in some cases, reach back farther than surviving material culture. Piri's claim that he worked from ancient charts is a historical statement that deserves to be taken seriously as a datum about how knowledge circulated in the pre-modern world. Whether those charts contained precise polar geometry is a separate question. The presence of such a claim, however, invites thoughtful cross-disciplinary work, reconstructions of cartographic lineages, digital experiments in projection and distortion, and targeted geological surveys of the specific regions the map seems to indicate. The Piri Reis map also serves another role in the broader narrative of Antarctica as archive. It is an example of how human testimony and physical evidence must be woven together carefully. Maps are not neutral windows, they are rhetorical objects with authors, audiences, and agendas. They compress complex topographies and uncertain knowledge into legible shapes. In an era when direct physical access to subglacial archives is increasing, via radar, seismic imaging, and targeted coring, it is tempting to use historical maps as treasure maps. That temptation must be disciplined by the recognition that cartography carries a history of error and that human memory is saved unevenly. The unresolved question the map leaves is therefore twofold and stubborn. On one level, it is poetic. Why did Piri's sources, whether ancient or medieval, sketch the southern seas in the ways they did? What cognitive and cultural steps lead a chain of navigators to imagine those coastlines? On the more practical, scientific level, the question is forensic. Can any features that the map seems to imply be reconciled with the geological and geophysical evidence beneath the ice? If so, do those features require an explanation that includes a known human presence? Or can they be explained by natural geological processes alone? Answering these questions means marrying disciplines that do not often speak the same language. It demands cartographic historians who can reconstruct possible source chains, geophysicists who can produce high-resolution maps of subglacial topography and sediment distribution, geochronologists who can establish when particular coasts were emergent or submerged, and chemists who can identify any anomalous anthropogenic signals in sediments. It also requires an ethical framework, even if a potential geomorphic target appears promising. Do the risks of invasive sampling outweigh the benefits? Some subglacial basins may host isolated ecosystems. The act of drilling into them could be irreversible. So the question of whether to treat Piri Reis as an investigative lead cannot be divorced from the contemporary responsibilities of science. That tension between the mapper's inspiring pointer and the mapper's unreliable witness is the engine of a larger psychological drama in the story. The map functions as a focal point for a longing to connect modern lives with a continuous, deep past. It tempts with the possibility of rejoining missing chapters. But it also forces humility. The planet archives in different media and with different fidelities. Stone, ice, sediment, and paper preserve different things. No single artifact is likely to contain the whole truth. The Piri Reis map, in short, is both a promise and a rebuke. It promises the possibility of continuity and rebukes the presumption that continuity is easy to demonstrate. In the end, the unresolved status of the map is itself a kind of answer. It suggests that discoveries about deep human antiquity and the fate of possible southern civilizations will not arrive as single, spectacular revelations unlocked by a single extraordinary artifact. Rather, they will emerge from the slow accumulation of congruent evidence, cartographic genealogy matched to sedimentary signatures, radar geometries cross-checked by gravity and magnetics, and, crucially, an ethical consensus about whether and how to sample. The map invites curiosity, but it also instructs patience. For listeners swept by the romance of lost continents, that conclusion may feel anticlimactic. For those who value an exacting method, it resonates with a different kind of exhilaration, the excitement of a slow, disciplined approach. that refuses to resolve complexity into comforting myth. The Piri Reis map remains a small, tattered door into the longer questions of human presence and memory, a door that opens onto corridors of inquiry rather than onto a single, illuminated chamber. The map has not been resolved. It continues to be a problem, a prompt, and a symbol. Whether it someday becomes a key to a new chapter of planetary history or remains a footnote in the history of cartographic transmission, it has already performed an important function. It has made explicit the logical pathways and the ethical checkpoints that any serious account of deep-time civilization must traverse. It has insisted that human documents be read alongside ice and sediment, that imagination be wedded to instrumentation, and that curiosity be restrained by care. The question that will travel forward from this part of the story is, therefore, not simply whether the map shows Antarctica before its great freeze. It is deeper and more austere. How does humanity reconcile its appetite for narrative continuity with the patient, often ambiguous evidence of planetary archives? The Piri Reis map does not answer that. It only demands that the question be asked again and more carefully, as instruments refine their sight and as researchers learn to listen in the layered languages of paper, ice, and stone. What does it mean to look at a map drawn in 1530 and to see, in its inked curves and embellished capes, the silhouette of a continent that, to modern observation, lies buried under kilometers of ice? How did mapmakers of the early 16th century arrive at coastlines that some read as the outline of a vast white land that was, for practical purposes, hidden for most of human history? The question folds into two strands that must be teased apart: the technical ways in which pre-modern cartography could create apparently accurate shapes, and the cultural ways in which rumor, secrecy, and the appetite for continuity convert ambiguity into myth. At the technical level, the craft of the mapmaker in Renaissance ports was a collage of memory, instrument readings, and second-hand reports. A cartographic fragment like the Piri Reis sheet is not a photograph of the world. It is a synthesis. Sailors returned with bearings and tales. Pilots sketched coastal profiles from the lee of a harbor. Compilers stitched together these sketches, adjusted for compass bearings, and attempted to translate a curved earth into flat vellum. The instruments were simple: cross staffs, astrolabes, early compasses, and the mathematics of longitude remained imprecise. Under those constraints, distortions proliferated. Coasts could be stretched or compressed. Islands could be transposed. The same headland might be recorded more than once with different names. But these technical distortions can, in certain arrangements, produce an image that resembles another, more distant reality. A projection error that lengthens a peninsula and curls a southern bulge might, by coincidence, resemble the outline of a shore now hidden beneath ice. When compilers worked from many sources, Portuguese pilot charts, Arab sailing directions, and older Portolan sheets attributed, and Piri's annotations to maps of Alexander, the final drawing could be a palimpsest of overlapping coastlines. Where blank spaces existed, imagination supplied fill. Speculative capes, imagined seas, recorded names that were less place than rumor. The hand of the mapmaker sought continuity across fragments, and in that effort, a coastline could purportedly mirror a shore that few living eyes had seen. A second set of technical practices, however, could make it seem that ancient mariners had, in fact, glimpsed southern shores. Mariners of the pre-modern and early modern era read the ocean for clues, driftwood, seabird patterns, and the content of floating detritus could all speak of nearby land. A log of a ship entering high latitudes might record the presence of bryophyte rich wood, seeds that came from temperate forests, or a flotsam that suggested a coastline not far away. Currents, such as the Antarctic circumpolar current, can carry material long distances. A piece of wood carrying pollen or bark could be mistaken for evidence of a nearby habitable shore. Bird behavior, large flocks departing in a single direction, a sudden presence of species known to nest on land could encourage a bold navigator to chart a nearby mainland. These are not proofs, they are instruments of inference in a world where direct sight often remained impossible. Beyond these sensory cues, there were human networks that transmitted knowledge. Whalers and sealers in the southern oceans, operating for centuries with scant fanfare, visited subantarctic islands and sometimes pressed farther south along pack ice margins. Their logs, rarely intended for scholarly posterity, contained practical charts, routes to a favored hole, the location of an open polynya, the extent of seasonal ice. Those charts were circulated among mariners. Port officials, merchants, and captains exchanged knowledge in ways that rarely filtered into official archives, but nevertheless altered common knowledge. A composite of such navigational lore could have reached cartographers like Piri Reis The map, then, may reflect a public record of private knowledge, fragments of everyday seafaring intelligence translated awkwardly into the formal language of a map. Yet a speculative impulse persists in the public imagination, that maps like Piri Reis are relics of something older and more consequential, a memory of a time when Antarctica was ice-free, and perhaps known to a civilization capable of charting it. The speculative documentary voice must treat this impulse with empathy and critique. On the one hand, there are real human reasons for why such a hypothesis feels compelling. The brain seeks narrative continuity. It prefers neat lineages to gaping silences. Discovering a single instrument, an inked coastline that seems to bridge the present to a warm coastal past, is emotionally powerful. On the other hand, extraordinary propositions require extraordinary evidence, and the material calculus of preservation over deep time is unsparing. Paper does not preserve climates. Maps preserve names and shapes filtered through centuries of copying, projection error, and selective memory. Rumors of secret survey expeditions sit at the intersection of those emotional and technical threads. They answer a simple psychological need. If the map is strikingly accurate, then perhaps someone, somewhere, must have seen what it depicts. This is where whispered histories gather, claims of clandestine voyages, of hidden logs, of naval hydrographers who mapped coasts and then buried their charts. The rumor is older than modern conspiracy. From the courts of early empires to naval yards to the 19th century, states have always guarded maritime intelligence that could confer strategic advantage. Hydrographic information soundings, currents, ice edge positions had tactical value. Governments, from imperial monarchies to modern nation-states, have commissioned secret surveys for reasons of commerce, security, and scientific prestige. There is a modest, well-documented truth in those rumors. Not all surveys have been public. Sealers, merchants, and naval reconnaissance sometimes preferred confidentiality. A profitable whaling ground is less valuable if crowded. Surveyors attached to colonial ventures occasionally withheld detailed charts for strategic reasons. In the 19th and early 20th centuries, the mapping of polar regions increasingly intersected with military interests, magnetic surveys for navigation, telegraph routes, and later the strategic calculus of polar basing. During the 20th century, aircraft reconnaissance and the cold logic of geopolitics accelerated interest in polar mapping. From hydrographers working for private firms to Navy detachments conducting covert soundings, the history of mapping is threaded with secrecy. That is the reason rumors find a plausibility anchor. But secrecy does not, by itself, substantiate the notion that early cartographers had access to precise depictions of an ice-free Antarctic shore. If secret surveys existed, they are more plausibly recent than ancient. The technology needed to map beneath ice or under persistent pack echo sounders, aerial photography, radar, does not belong to the age of sail. The notion that 16th century mariners had topographic knowledge of a coast now under kilometers of ice is as much a test of cartographic interpretation as it is an historical claim. If knowledge of the Antarctic coast existed long ago, it would most likely be fragmentary and mediated through a sequence of maps and reports rather than drawn from a single archetypal chart of a highly advanced pre-glacial civilization. Another axis on which the rumors turn is the human tendency to conflate absence of evidence with evidence of absence. The deep past is silent in places where the geological and glacial processes have erased or disguised artifacts. The absence of a preserved ruin is not a proof that no complex societies ever existed. Neither is it proof that they did. The prudent stance is to enumerate where survivals are plausible. Coastal lowlands that were rapidly buried in anoxic sediments have the highest chance of preserving chemical and geochemical anomalies, concentrations of metals, persistent synthetic compounds, unusual isotopic ratios that would mark industrial or technological activity. These are the signatures modern science seeks. They are also the signatures that clandestine survey efforts, hidden or public, would prioritize locating. Yet the step from "we should survey" to "they surveyed and found" is not automatic. The rumor mill generates a secondary consequence, narratives of suppression. If secret surveys took place, and if they purportedly found evidence of something startling, why would such findings not enter public science? The documentary voice addresses this question with a recognition of institutional incentives. Scientific publication is the currency of credibility, peer review, replication, and openness are the corrective mechanisms that allow a stray signal to become accepted knowledge. Long-standing, extraordinary claims require multiple teams, independent methods, and reproducible samples. If a government agency did possess an anomalous core sample or a strange radar return, the ethical and professional impetus of career scientists would push towards sharing it. That is not to say politics and secrecy can never impede scientific exchange. They sometimes do. But the likelihood that a robust, verifiable piece of evidence, an isotopic fingerprint inconsistent with natural cycles, a synthetic molecular residue of ancient manufacture, would remain wholly unpublished inside a single organization is, statistically, small. Rumors of furtive expeditions also have an emotional function. They transform the map into an invitation and the unknown into a quest. That dynamic can be propulsive in a positive sense. It motivates more open, interdisciplinary exploration. It can also be corrosive. It fosters a marketplace of certainty that privileges sensational narratives over patient, cumulative science. The narrative arts, including documentary storytelling, must be vigilant in distinguishing the productive curiosity that rumor can kindle from the epistemic habits rumor can undermine. A third explanatory track reconciles both map-making and rumor, the slow accumulation of error and the preservation of tidbits across millennia. An ancient mariner may have glimpsed a transient open coast during an exceptionally warm interglacial and recorded a vague coastline. That smudge of observation could have been copied and copied again, adjusted to new reference frames, and imbued with the authority of earlier sources by later map makers. If that chain of transmission converged with later secret or semi-secret hydrological knowledge soundings recorded by whalers, ice edge positions logged by sealers, a naval reconnaissance chart, then a modern observer might see the overlay as substantive continuity. The result is an image of the past that feels coherent because disparate fragments have been stitched together. In that sense, both the map and the rumor are true. They are different modes of a longer human attempt to exchange and preserve knowledge across time and across the erasures imposed by ice. Finally, the story of secret surveys and map anomalies is inseparable from an ethical knot about how humanity approaches the planet's hidden archives. Curiosity is a noble engine of discovery, but the act of probing beneath ice carries consequences. Drilling into subglacial basins risks contaminating ecosystems that may have evolved in isolation for millions of years. Mapping missions that prioritize strategic advantage over scientific transparency can damage trust and retard collaborative inquiry. The very metaphors of secrecy, anomalous charts hidden away, obscure an equally important reality, that the most robust discoveries come from open, cross-validated science that subjects extraordinary claims to collective scrutiny. When the question is posed, how did people in 1530 appear to know the shape of a continent now buried in ice? The answer is necessarily layered. Part technical, part cultural, part psychological, it is the product of cartographic practice, maritime intelligence, and the human hunger for continuity. Some of that hunger manifests as rumor, whispered accounts of covert expeditions that mapped secret coasts. Some of it is supplied by the pragmatic realities of sailing, driftwood, birds, and currents that point toward land. Much of it comes from the archival nature of maps themselves. They are cumulative objects, built on older charts and second-hand testimonies. The proper response is not to extinguish curiosity, but to redirect it. Rumors do not become evidence by repetition. They become hypotheses to be tested. They demand methods that are slow, precise, and ethically considered. The overlay of historical source criticism with geophysical surveys, the matching of cartographic lineage to sedimentary and isotopic records, the sober accounting of where preservation is plausible and where it is not. The history of mapping and the history of hidden expeditions are, in that sense, invitations to look more closely, to cross-check, to treat sensational resemblance as the beginning of inquiry rather than its conclusion. Beneath that invitation lies a quieter, almost metaphysical lesson. The map drawn in 1530 and the murmurs of secret voyages both point to the same deep human predicament. That much of the world's past is not a continuous narrative, but a palimpsest of fragments. The continent under ice is not merely a repository of objects, it is a mirror in which humans see the limits of memory and the courage of patience. The seduction of a single revealing chart or of the myth of clandestine discovery must be balanced by the sober work of instruments, laboratories, and shared ethics. Only through that discipline can the hints embedded in maps and rumors be transformed into the kind of durable knowledge that redraws, carefully and credibly, the outlines of planetary history. What would it mean if the cold vaults of 20th century states, the Luftwaffe's logbooks, naval hydrographic reels, the cassette stacks of satellite reconnaissance agencies contained images or scans that hinted at something not entirely explained by glaciers and bedrock? That question, small and blunt, reframes the entire history of polar exploration in a different light. It asks not whether humans once set foot upon a warmer Antarctic shore. The geological record already answers that in measured registers of pollen, peat, and leaf imprints, but whether the politics and technologies of the last century left an archival footprint so deep and so partially hidden that it shapes what is still sought beneath the ice. There is a compact historical fact that often gets enlarged into myth in the early and mid-decades of the 20th century. Three complex and ambitious state systems directed attention toward the poles with an intensity that was part science, part strategy. Nazi Germany sent an expedition south in 1938-1939 whose stated purpose combined whaling rights with mapping. The United States mounted Operation High Jump in 1946-47, the largest Antarctic expedition to date, with naval, aerial, and support fleets gathering cartographic and logistic information, and the Soviet Union, from the 1950s onward, invested heavily in polar stations, geophysical surveys, and ice-penetrating studies. Each of these efforts left behind a trail of data: aerial photography, sonar profiles, magnetometer logs, early radar echoes. The raw numbers and film strips transformed into maps, reports, and archives, some of them published, many of them reduced to classified appendices or stored in government vaults. That archival tension, the coexistence of disclosed science with withheld material, is not merely bureaucratic dullness. It has psychological contours. Classification is a practice designed to make uncertainty into control. To seal a set of images away is to declare them valuable enough to be politically managed. Secrecy, in turn, breeds imagination. In a world where public knowledge is slender, every missing page becomes fertile ground for narratives about hidden cities, secret bases, or proof of ancient sophistication. The history of 20th century polar work therefore functions on two registers: the tangible technical achievements of mapping and instrumentation, and the cultural afterlife of partial disclosure. It is important to separate the empirical from the speculative before tracing the emotional landscape that follows. Technically, the nations of the 20th century developed tools that radically extended human vision beneath ice. Airborne photogrammetry established broad coastal outlines. Sonar profiled bathymetry under sea ice. Radio echo sounding began to reveal subglacial morphology. These techniques gave scientists new ways to detect cavities, layered sediments, and the subtle bumps of buried valleys. During the Cold War, these same instruments acquired strategic purpose. Subglacial valleys could channel rivers, low-lying basins could serve as hidden approach lanes for submarines beneath pack ice, and gravimetric anomalies could indicate dense mineralization useful to an industrializing war economy. The line between scientific curiosity and military utility blurred. Where utility exists, secrecy follows. Some datasets were and remain genuinely sensitive. Early satellite imagery was national treasure. The first generations of reconnaissance satellites produced photographs that could show not only landforms but installations and human activity. The partial declassification of programs like Corona in the 1990s released valuable Earth science imagery that had been unavailable to civilian researchers for decades. But among the thousands of frames that entered the public archive were also records still withheld, partly because their existence intersects with matters of national security, partly because raw frames can be misinterpreted and used in disinformation campaigns. That fact is consequential for the Antarctic narrative. It means that, in some cases, geophysical hints that would be worth re-examining by contemporary scientists remain tied up in redaction stamps and classified catalogs. The consequence is twofold. On the one hand, there is a legitimate frustration among researchers who recognize the utility of historical baselines for interpreting present anomalies. A radar echo collected by an expedition in the 1950s that appears oddly geometric is a far stronger lead when juxtaposed with a corresponding 1947 aerial photograph or a later gravimetric survey. Pattern matching across decades is how noise becomes signal. On the other hand, secrecy is not a conspiratorial act but a constraint. Many of the records that would most interest an international scientific community were produced in security contexts, and releasing them is a political act as much as a scholarly one. The tension between the need to know and the impulse to guard knowledge shapes the story's moral atmosphere. So what might actually be hiding beneath the ice that would justify both curiosity and secrecy? To answer, the narrator must shift modes from historical recounting to forensic imagination grounded in preservational logic. The range of plausible hidden things falls into several classes, each with distinct signatures and different odds of surviving into any archive. First, there are the recent anthropogenic imprints, 20th century structures, caches, or experimental installations. These would be the easiest to identify and the most likely to have left a retrievable trace. A mid-century encampment, for instance, might have left concentrated deposits of metals, fuel residues, battery casings, scrap steel, producing localized magnetic highs and elevated transition metal concentrations in underlying sediments. Plastics and polymers, while chemically susceptible to breakdown over centuries, can leave detectable molecular fragments or unexpected organic signatures. Nuclear-era activities, even small-scale tests or accidental releases, would leave particular isotopic fingerprints. Certain radionuclides, depending on half-lives and geochemistry, can serve as incontrovertible markers of anthropogenic processes. In short, modern installations, even if later buried, tend to leave anomalies that contemporary instruments can detect if cross-checked carefully. Second, the hidden things might be geologic or hydrogeologic features that mimic artifice to an untrained eye. Regular terraces, rectilinear ridges, or evenly spaced reflectors can arise from jointing in bedrock, differential erosion along fracture systems, or the action of subglacial meltwater carving repeated channels. Such features can be mistaken for foundations or roads when viewed in a single dataset. Only by layering radar, seismic, magnetic, comet, and gravity data, and by retrieving cores to read the chemistry of the sediments, can natural structure be disentangled from the possibility of design. This is the mundane but crucial truth of polar exploration. The planet's processes can produce the semblance of intention without any living agent at all. Third, and most haunting for speculative imaginations, are the possibilities that transcend a single human epoch. Chemical anomalies that suggest an industrial-scale input far earlier than modern history, concentrated platinum group elements, abrupt shifts in carbon isotopic composition inconsistent with natural cycles, or the presence of synthetic molecules not found in natural geochemical pathways. These would be the sorts of residues most likely to survive deep time and to force a rethinking of the human footprint. But the bar for claim is correspondingly high. Earth's geochemistry is complex. Diagenesis can redistribute elements. Anomalies require multiple, independent lines of evidence to be convincing. If any of these signatures were to appear in a flagged set of archived radar images or in a recently declassified film strip, the response would not be uniform. The initial human reaction would be electric, thrill and dismay braided together. Thrill, because the prospect of reading a new chapter of planetary narrative from under the ice is a rare and intoxicating possibility. Dismay, because the stakes are philosophical and political. A credible discovery of human-made structure older than the Holocene would not simply rewrite prehistory, it would rewrite the frameworks by which disciplines allocate evidence. For institutions, there is a managerial dread. Verification is slow. The cost of false affirmative claims is enormous. And for the public, such a discovery would release powerful metaphors about continuity, loss, and the impermanence of human endeavors. In practice, a discovery would trigger sequences already rehearsed in the quieter chambers of science, replication, cross-validation, and transparency. The most responsible path is institutional triangulation. Independent teams obtaining access to the archival materials, applying modern image processing techniques, overlaying multi-sensor geophysics, and, only if the evidence accumulates robustly, undertaking carefully controlled coring operations. Ethical frameworks would come to the fore. The Antarctic Treaty System, with its emphasis on environmental protection and international cooperation, provides a legal matrix for such actions. But law is not a panacea. Questions of stewardship would remain. Is it better to leave an anomalous site untouched, preserving potential subglacial ecosystems, or to sample and risk contamination in order to resolve a question of immense human significance? The answer is not purely scientific, it is ethical. Governments would feel the pressure too. The geopolitical history that produced the classified records matters in the politics of disclosure. Any state still holding relevant files would need to balance the national impulse to maintain advantage against a broader responsibility to the global commons of knowledge. Public release of archival imagery could itself be a destabilizing act. It could stimulate a wave of private expeditionary interest, tourist speculation, or even malicious exploitation. The risk of rumor metastasizing into action, of treasure-seeking teams rushing fragile sites, is not theoretical. The contemporary world has seen precisely such dynamics unfold around archaeological controversies and unguarded heritage sites. The Antarctic context intensifies the ethical calculus. The environment is uniquely sensitive, and the logistical costs of any intervention are high. The emotional syntax of all this is complex. At the level of the scientific collective, there is a quiet, rigorous excitement, the kind that comes with a puzzle that might reorder classification schemes and require new methods. At the level of public imagination, there is a hunger for spectacle and narrative closure. And beneath both, there is an existential chill, the recognition that even mighty human enterprises, nations, technologies, myths may be ephemeral in the face of glacial advance in geological time. That chill can provoke humility or hubris. Responsible scholarship tends toward the former, conspiracy and sensationalism toward the latter. There is a final, reflexive lesson embedded in the history of 20th century secrecy and polar science. The very fact that states once collected extensive and sometimes concealed polar data is not proof that secrets of civilizational magnitude remain hidden beneath the ice. It is, instead, proof of a different kind, that the archive of human activity is messy, partial, and politically inflected. It means the search must be practiced with care, not in the spirit of conquest, but in that of forensic patience. It means that when an anomalous radar image is found in a cold vault, the first question must be methodological. What else could produce that signature? The second must be institutional, who must see and vet this material so that claims, when made, rest upon ironclad replication. If, after all due diligence, the evidence pointed toward an artificial origin, whether modern, medieval, or ancient, the world would face not a single revelation but a cascade of responsibilities, scientific verification, ethical restraint, international governance, and a sober public conversation about what it means to discover something that reframes human history. The decision-making would not be only archaeological or geological, it would be moral and diplomatic. The 20th century's secretive forays into polar space thus remain, in the end, both promise and caution. Their classified reels and withheld radar images are not simply hints of hidden artifacts. They are reminders of how knowledge has been accumulated and controlled. They teach that the act of discovery is inseparable from the social arrangements that govern disclosure. They insist that if something is truly found beneath the ice, the way humanity responds will matter as much as the finding itself. The instrument's echo, the archive's stamp, the treaty's clause, these are the elements that will determine whether the discovery opens a door to shared understanding or becomes another page in the ledger of polarized secrecy. The narrator leaves this part with the same precise, somber curiosity with which scientists approach a promising anomaly, an attitude that is at once open to the larger surprises and anchored in a disciplined skepticism. For beneath the ice, the question remains as patient and as inexorable as the glacier's flow. If something designed by human hands exists there, then it has left the kinds of traces that modern science can, in principle, read. Whether those traces will be found in declassified film, in a drawer of magnetic tapes, or in a newly extracted core is unknowable. What is known is simpler and harder. To seek responsibly is to listen broadly, to triangulate cautiously, and to remember that the planet keeps its longest stories in scripts that are chemical, geometric, and, above all, indifferent to human drama. What would it mean in human terms to move from the faint traces of ancient microbes to evidence so strange that it resists classification? To pass from the known alphabet of life's biochemical scripts into a page whose ink does not match any hand? The question is at once scientific and existential. It is the hinge between two kinds of discovery, the small, patient accumulation of data that modestly revises understanding, and the rare convulsive finding that forces a reordering of categories. In the frozen archives beneath Antarctica, that hinge gleams. Microbial life and molecular fossils are common subjects of methodical paleobiology. Unidentifiable anomalies are the kind of signal that, if genuine, would make scholars pause and nations look inward. The first register of this inquiry is utterly ordinary, microbes and the molecular ghosts they leave behind. Life is a chemistry of persistence. When cells die, their fragile internal machinery falls apart, but some components endure. Lipids, the molecular backbones of cell membranes, are chemically robust. Over geological timescales, they can be transformed into hopenaes and steranes, recognizable molecular fossils that speak in syllables about bacterial types, algal lineages, and even the broad contours of ancient ecosystems. Kerogen, the complex residue of once living organic matter, carries fingerprints of biological activity in its hydrogen-to-carbon ratios and in subtler biomarkers embedded within its matrix. Stable isotopes, particularly of carbon and nitrogen, carry the imprint of metabolic pathways. Photosynthesis leaves a different isotopic trace than chemosynthesis. Methanogenesis produces a distinct signature from aerobic respiration. Sensitivity and specificity are the twin virtues of these methods. Mass spectrometers and chromatography rigs do not see a creature, they measure ratios and molecular fragments. A sediment core can thus yield a consortium of low-level evidence, an abundance peak of certain sterins at a horizon, a correlated excursion in NEX Nth13C signaling a perturbation in the carbon cycle, a suite of lipids that together point to bacterial mats or to peat-forming wetlands. In Antarctic settings, such concordant signals would be striking precisely because they would sit under kilometers of ice that, to the modern eye, suggest eternal cold. They would be the biochemical memory of a different climate regime, a modest, cumulative testimony of warmth and life. But there are limits to what these molecular scripts can say. Ancient DNA, the once arresting dream of reading genetic sequences back through time, degrades relentlessly. In most natural contexts, recoverable DNA becomes vanishingly rare beyond a few 100,000 years. Protein fragments persist longer but undergo diagenetic alteration. Therefore, the most enduring witnesses are the chemistry of lipid residues, mineral-hosted biomarkers, and isotopic ratios. They speak of ecology and metabolism, not of language or of cities. That asymmetry is central to any sober reckoning with the past. Large-scale human constructions tend not to leave the kinds of persistent chemical signatures that will travel unchanged across millions of years. What survives best is the simplest and the most chemically inert, a paradoxical humility at the heart of deep time. Against that measured backdrop, the notion of an unidentifiable signal takes on its shape. In laboratory terms, unidentifiable means a reproducible measurement that resists interpretation against known databases and models. It might be a molecular compound with a backbone of monomers not present in biotic chemistry, a polymer whose stereochemistry is inconsistent with biological synthesis. It might be an isotopic ratio that sits outside terrestrial baselines, a 15N or 13C value that does not fit known biogeochemical cycles, or a suite of noble gas concentrations that cannot be accounted for by diagenetic or mantle processes. It might be microstructures, ordered, repeating patterns at microscopic scales, preserved in sedimentary minerals, that mimic purposeful fabrication more than random mineral growth. Or it might be a combination, a chemical anomaly co-located with a geometric echo beneath ice, where radar suggests a repeating morphology and a core returns a pulse of molecular oddities. All such findings, if robust, would provoke the same sequence of responses in the scientific community: deep skepticism, intense replication, and a hunger for multiple independent lines of corroboration. The history of science teaches that the most extraordinary claims are also the most vulnerable to contamination. Instrument artifacts, or interpretative overreach. Chemical residues are especially treacherous. Modern pollution, laboratory reagents, and drilling fluids can leave traces that mimic ancient compounds. Diagenesis, the suite of changes induced by heat, pressure, and time, can rearrange molecular structures into forms that look unfamiliar. An isotope anomaly can be generated by fractionation during geochemical alteration rather than by a unique biological or technological event. There is, nonetheless, a domain of plausible exceptions that cannot be ignored. Subglacial refugia, isolated lakes and basins sealed beneath ice for millions of years, are not merely colder versions of surface lakes. They are chemical laboratories in which life, if present, would have followed metabolic pathways shaped by perpetual darkness, pressure, and limited electron acceptors. Microbial communities adapted to sulfate reduction, iron oxidation, hydrogenotrophy, or ammonia-driven metabolisms can produce molecules uncommon in surface settings. Moreover, prolonged isolation can lead to molecular novelties in metabolism, enzymatic innovations, unexpected cofactors that would leave unfamiliar biochemical traces. Those traces would be unidentifiable only because current reference libraries are biased towards surface ecosystems and the biochemistry of extant, well-studied microbes. The possibility of technological signatures is a different category, one fraught with both methodological restraint and cultural drama. What would constitute chemical evidence of past technological activity? The most decisive kinds of signatures would be those that are extremely unlikely to originate in natural geology. Large, coherent enrichments of rare transition metals and patterns inconsistent with ore formation, persistent synthetic organic polymers, with monomer sequences not seen in biology, isotopic patterns of fission products or transuranic elements that cannot arise from natural nuclear processes, yet the plausibility of such signatures surviving into deep time is constrained by physics and chemistry. Many radioisotopes have half-lives far too short to be detectable after millions of years. Metals are mobile in aqueous systems and can be leached, concentrated, or dispersed by diagenesis. Synthetic organics can polymerize, hydrolyze, or be depolymerized by microbes. The burden of proof for a technological origin, therefore, is correspondingly high. This is where the question of secrecy and danger enters. The image that circulates in popular imagination is simple and dramatic. A piece of data, a core, a radar map, a spectroscopic scan, is bundled away by an agency because its implications are too destabilizing. There is a psychological clarity to that narrative. Knowledge kept secret, presumably, because it threatens existing orders. The reality is more complicated, and where complication lives, fear tends to gather. There are legitimate reasons why potentially anomalous findings will be withheld, at least temporarily. Biosecurity is primary among them. If a recovered sample appears to contain viable microbes with novel metabolisms, the risks are not merely speculative. Organisms immunologically unfamiliar to modern ecosystems could, in principle, interact in unforeseen ways. The Antarctic treaty system and scientific communities have long recognized that the act of sampling isolated environments demand stringent sterilization and containment protocols. The principle is simple. A discovery left sealed is safer than a discovery disseminated. That logic supports temporary restrictions on data release while containment studies, hazard assessments, and ethical deliberations proceed. A second legitimate reason is methodological prudence. The premature public announcement of an anomalous measurement, one later shown to be an artifact of contamination or instrument error, does more than embarrass the researchers. It breeds public confusion, erodes trust in institutions, and politicizes curiosity. The modern record contains many examples of findings that, when sensationally reported, spun into cultural narratives without the ballast of replication. Responsible science, therefore, often requires a period of closed verification, independent laboratories retesting samples, blind replication experiments, and the layering of complementary data sets. Only when anomalies survive this gauntlet should they be aired for public deliberation. A third practical driver of secrecy can be geopolitical. If a discovery bears on resources, a concentration of a rare element, states may wish to avoid premature disclosure that could instigate competitive rushes. If a finding intersects with strategic capabilities, there will be pressure to control narratives. Again, this is not necessarily a grand conspiracy. It is the arithmetic of national interest. But the institutional impulse to shield information for security reasons can be misread, especially in an era of instant communication and interpretive hunger. Those legitimate motives, however, exist in tension with the principle of open science. Knowledge, to be credible, needs communities of scrutiny. A finding that challenges foundational assumptions about human history or about life's variety cannot be adjudicated within a single government dossier. It needs replication, peer review, and the cross-disciplinary exchange that transforms novelty into a robust addition to the human record. The ideal path is therefore a staged one. Containment and verification should precede public disclosure, but existential claims should not be locked away indefinitely under the guise of caution. This delicate balance is the seat of moral responsibility. Scientists, custodians of data, and policymakers must navigate an ethical landscape shaped by precaution, transparency, and humility. Several procedural guardrails suggest themselves. First, immediate physical containment and biosecurity assessments upon the discovery of potentially viable organisms. Second, the creation of international, interdisciplinary teams that can be granted secure access to samples under protocols that protect both biosecurity and scientific integrity. Third, rapid but careful data sharing of non-sensitive results, geophysical maps, baseline chemical spectra, isotopic ratios, so that independent replication is possible without releasing materials that might pose biological risks. Fourth, a commitment to public communication that distinguishes provisional findings from robust conclusions, that explains uncertainty rather than obscuring it. The narrative impulse that frames such discoveries as too dangerous to tell also trades on psychological motifs older than science. The idea of forbidden knowledge, the fear that some truths will upend comforting stories. That motif can be harnessed to good or ill. It can inspire rigorous precaution, or it can be weaponized to hide malpractice. The Brent's turns on transparency of method and institutional accountability. where the scientific community and international governance create clear, open pathways for verification, secrecy is rare and short-lived. Where institutions are opaque and power concentrated, rumor thrives. There is one further danger to consider that is not merely physical or political, but epistemic, the tendency to convert unidentifiable into intentionally mysterious. The human brain is an extraordinary pattern finder, eager to fill gaps with narrative. A molecular oddity in a core, a geometric echo in radar, and a marginal annotation on an old map can be woven into a coherent story of lost intelligence if the listener is willing to. Privilege fit over proof. The discipline of science resists that tendency by insisting on falsifiability and on the slow accumulation of convergent evidence. That discipline can feel impatient to a public that craves drama, but it is precisely that slowness that protects knowledge from the seductions of story. Finally, the cultural implications of even a provisional hint of something genuinely unidentifiable must be acknowledged. Human societies build narratives about origins and centrality, the rearrangement of timelines, or of the uniqueness of human achievement has ripple effects that extend beyond academia. The prospect of encountering an element of the past that cannot be readily explained, chemical or morphological strata that demand an expansion of categories, would provoke wonder, anxiety, and a reorientation of meaning. That is not a reason to suppress curiosity. It is a reason to prepare. Public education, ethical deliberation, and the international stewardship of research infrastructure are part of that preparation. The most responsible posture, in this story and in real life, is therefore a compound of wonder and restraint. Wonder is the engine that sends instruments into the field. Restraint is the discipline that prevents a single anomalous signal from becoming a false epoch. If beneath Antarctica there dwells an archive that contains microbially rich refugia and, perhaps, molecular anomalies that challenge known chemistry, the proper response is methodical, isolate and secure, replicate and cross-validate, open where safe and slow where necessary. Secrecy may be warranted in the short term for biosafety. It becomes a problem only if it substitutes opacity for procedure. In the end, the emotional tone that pervades this part of the inquiry returns to the story's constant companion, humility. The Earth writes in slow, patient ink. Its archives favor chemistry over narrative, isotopes over monuments, subtlety over spectacle. The possibility that beneath kilometers of ice there are microbes that have rewritten the grammar of metabolism, or chemical residues that momentarily stand outside known categories, is both thrilling and fraught. It is thrilling because it would extend the imagination of what life and history might be. It is fraught because of the responsibilities that such knowledge imposes. The listener is left with a twofold image. The first is microscopic, an ancient cell, its membrane chemistry fossilized in a molecular fossil, carrying a whisper of a warm shore now entombed. The second is vast and ethical, a sealed lab, an international committee, a core sample opening under the hum of instruments, and the slow passing of evidence from locked drawers into the light. Between these images sits the real work of discovery, patient, collaborative, and governed by a recognition that some of the planet's longest stories demand not only the courage to seek them, but also the discipline to steward them well. Whether the unidentifiable beneath the ice turns out to be an exotic microbe, an abiotic chimera, or a chemical that rewrites categories, the lesson will be the same. The planet's deep memory is generous in fragments and stingy in certainty, and humanity must learn to read those fragments with care. What happens when the sleeping chemistry of a world stirs again? What is the meaning of an ancient microbe? Dormant for millions of years, twitching back into metabolism under the probing of a drill bit or the slow heat of a thaw. Those questions sit at the center of a new register of uncertainty, not merely about what the ice preserves, but about the ethical grammar that governs what humans choose to reveal or to conceal when that preservation coughs and spits out the unexpected. The image is small and biochemical, a single cell, its membranes folded like a folded note, its enzymes crystallized into a near motionless architecture by cold and time. In the safe, sealed dark of a laboratory, instruments warm a sample just enough to wake it. Under the microscope, movement reappears, the slow rotation of a flagellum, the rearrangement of cell walls, the reactivation of pathways long dormant. That scene has an ordinary counterpart in modern polar science. Subglacial lakes and buried sediments have yielded microbes that metabolize sulfur, iron, and hydrogen in ways that are unusual but not unthinkable. The novel and the unsettling is the scale. Life that has been isolated beneath kilometers of ice for epochs longer than the span of civilizations, possessing biochemical adaptations unfamiliar to most terrestrial ecologists. Such revivals are not merely curiosities. They carry both practical and philosophical weight. Practically, every revived organism is a data point for how life endures under extremes, how metabolism rewrites itself when sunlight never arrives, how chemical energy is recycled in closed systems. These are the kinds of insights that seed new theories of habitability both on Earth and on worlds beyond. Philosophically, the awakening of ancient microbes obliges a reconsideration of continuity. Life persists in ways that outlast monuments, languages, and perhaps even the meaning systems that humans cherish. The planet's biological memory is written in molecules. It does not depend on continuity of narrative. Within that double register, practical and philosophical, there is another dimension that complicates the story: secrecy. Not every discovery travels immediately into the archival sunshine. Over the last decades, there have been instances where samples, or at least fragments of their analyses, were withheld from broad publication. The reasons for classification are multiple and sometimes overlapping: biosecurity precaution, proprietary research agendas, national prestige, and institutional caution against premature claims that might later be refuted. The classification of some cores and microbial isolates is not yet proof of a hidden conspiracy. It is testimony to the anxieties that attend any finding located at the intersection of novelty, risk, and legitimacy. Biosecurity is the most defensible rationale. When a sample yields organisms with unknown metabolisms, the natural response is to secure it. Laboratory protocols demand containment until risks are assessed. Ethics require that potential hazards be evaluated before public dissemination. The Antarctic Treaty System and professional codes of conduct both lean toward that cautious stance. It is better to study a strange organism in a high-containment facility before allowing it to be shipped and handled broadly. In an age when a single microorganism can alter ecosystems or be weaponized, prudence can appear as secrecy. The line between responsible withholding and opaque concealment becomes legally and morally porous. Another motive for classification is institutional and political. A result that seems to upend established chronologies or that could be spun in nationalistic narratives invites careful custodianship. Laboratory groups and governments alike worry about false positives, sensational headlines, or the reputational damage of a claim that collapses under later scrutiny. There is an understandable temptation to pause, replicate, and verify in private, but that very prudence can be misread as obfuscation. Cultural consequence is a fertile ground for rumor. Fragments of an extraordinary result leak. The public imagination fills the gaps with lost cities and suppressed epochs. Mistrust. Organics like mold. The interplay between revived microbes and classified samples, between what wakes and what is withheld, raises a question that is less technical than existential. If the preserved biosphere can return fragments of a past life, to whom does that past belong? To the planet, to the international scientific commons, to nation-states that funded the operations, to future generations whose rights might be impacted by disclosure decisions? The quandary is not theoretical. It shapes decisions about whether to publish the genome of a novel microbe, whether to share raw geochemical profiles, and whether to open a subglacial site to collaborative investigation. Each choice is a claim about stewardship, and that, inevitably, leads to a larger and far more contentious question. What if this place, the frozen white continent that archived eons, was once not only a habitat but a cradle? What if, in a long reticulation of the planet's deep time, a form of social complexity and material culture once flourished and was later entombed by climate? The simple phrasing, a cradle of civilization, carries enormous freight. Civilization, as a word, points to organized social systems that produce durable technological signatures, metallurgy, large-scale earthworks, synthetic compounds, radiogenic anomalies. If Antarctica were such a cradle, the nature of survivals and the ways humans should respond to their recovery would be profoundly different from the episodic revival of microbes. The first matter of sober response is a temporal arithmetic. Civilizations, in the sense understood by modern archaeology and history, bloom and fade on timescales that are brief compared to geological epochs. The most durable monuments, stone, fired ceramics, slag heaps, erode, break down, and are reworked by tectonics and ice. Over millions of years, even the hardiest lithic record is vulnerable. The epistemic expectation, therefore, must shift from imagining intact buildings to searching for the enduring impressions of industrial activity, concentrated traces of rare metals and sediment horizons, Molecular residues that do not arise from known biogeochemical pathways, isotopic signatures of nuclear fission, or anomalous distributions of transition elements that resist natural explanations. Those are the kinds of residues that, if they exist, would be legible across deep time. They are also the kinds of things that laboratories can measure with exquisite sensitivity. A statistically significant cluster of platinum group elements in a discrete, well-dated layer, coinciding with an isotopic excursion in carbon inconsistent with natural processes, would be the kind of finding that cannot be explained away by ordinary diagenesis. Likewise, the detection of long-chain synthetic polymers in a sealed sediment horizon would be a material fingerprint of. Manufacturing that begs explanation. Yet the plausibility of such gestures surviving is constrained by several hard variables. Diagenesis moves and redistributes elements. Fluids percolating through sediments can leach or concentrate metals. Heat and pressure rewrite molecular structures. Plate motions rearrange crustal blocks, glaciation scours and buries. The region's geological volatility dictates that the places with the highest chances of preserving exceptional material are precisely those that isolate and protect it. Anoxic basins, rapidly buried peat bogs, or sediments sealed beneath great ice streams where chemical alteration slows to geological molasses. The search, therefore, must be targeted to those depositional contexts where preservation potential is highest. If the cradle scenario is given a speculative hearing, its social and cultural implications also deserve careful unpacking. Discovering evidence that human-like intelligence, once organized at a scale compatible with civilization, would refract. Questions outward about human uniqueness, about continuity and rupture in cultural histories, about the ethics of claiming a lineage with the distant past. The discovery would be destabilizing in a modest sense, a required rethinking of timelines, and in a grander, symbolic sense. Narratives of exceptionalism would confront a broader canvas in which human technological activity appears as one episode among many in the planet's long procession. That symbolic unsettlement is not merely aesthetic. It becomes legal and political. If material artifacts or chemical signatures of ancient manufacture are found within a national, claim under the Antarctic Treaty who has the right to investigate them, to own samples, and to narrate the findings. The treaty privileges scientific cooperation and environmental protection, but in practice, the control of compelling data can create sharp incentives for states to assert priority, delay disclosure, or condition access. Classification, again, may emerge not as a conspiratorial tactic, but as a reflexive defense of geopolitical interest. There are also ethical imperatives that counsel against immediate exploitation. If a place once hosted complex life or social organization, it may have also hosted ecosystems and biomes unique to that period. Disturbing sealed basins risks not only biological contamination, but the loss of irreplaceable contextual information. Excavation destroys stratigraphy. Sampling is an act of violence against a buried archive. The scientific ethic of minimal invasiveness becomes crucial. The desire to know must be balanced against the duty to preserve as much of the archive as possible for future, more refined inquiries. Public reaction to the possibility of an antediluvian Antarctic cradle would predictably oscillate between rapture and fear. Myths would rush in to fill gaps. For some, the idea would affirm long-standing speculations about lost southern continents and ancient navigational traditions. For others, it would provoke an existential unease. Civilizations can vanish without substantive trace. What does that say about the durability of current human achievements? The cultural hunger for neat narratives. Discover a lost city. Publish. A single photograph collides with the observed reality of deep time, which often disallows neat resolutions. This tension points back to method. The responsible approach to any hint of human-shaped signatures beneath the ice is layered and slow. Remote sensing, radar acoustics, gravity, magnetics must guide the priorities of where to core. When cores are extracted, protocols of sterilization and containment should be rigorous. Chemical and isotopic assays require replication across independent laboratories. Where biological materials are recovered, containment and biohazard assessment must be prioritized before public release. And crucially, an international panel composed of geologists, chemists, paleobiologists, ethicists, and representatives of the Antarctic governance system should oversee decision-making to reduce the risk that isolated institutional interests guide disclosure. The conversation about what Antarctica might have been is also a conversation about what humanity wants to be. The Panis archives do not exist for human retrieval. They endure with or without human attention. But humans have the unique capacity and moral obligation to interpret, preserve, and communicate those archives responsibly. If microbes wake and are placed in cold boxes labeled classified, that act reflects more about human institutions than about the microbes themselves. If a chemical anomaly hints at past manufacture and is sequestered, the decision to sequester will ripple across disciplines and publics. The central moral question is not whether to know, it is how to know in ways that honor both the record and the living world. In the end, the oscillation between the revival of single-celled life and the speculative dream of a cradle of civilization in the ice returns the listener to a quieter, deeper attitude, humility. Earth's temporal vastness reframes the drama of discovery. The planet archives in molecules and isotopes, in quiet reflectors under ice, in pollen and peat. It does not preserve narratives the way human minds prefer. The most radical discoveries are unlikely to appear as museums under snow. They will come as convergent anomalies, chemical, geometric, isotopic, that, when stitched together, revise probabilities and open new questions. That is a kind of tragic beauty, even as some samples are kept in trunks stamped with restricted stamps, and as some anomalies linger in vaults, the larger story continues to be written in patient, collaborative work. Instruments will improve, protocols will sharpen, international governance will be tested and, one hopes, strengthened. Meanwhile, the microbes will sleep and wake, the sediments will keep their quiet record, and the human archive of rumor and caution will grow. The ethical imperative is to steward curiosity, to listen, to replicate, to protect, and to tell the public a truth proportionate to the evidence. To do otherwise would be to substitute the brief exhilaration of legend for the slow, durable work of understanding. If this white continent was once a cradle, it will not be revealed by one sensationalist photograph or by a single released core. It will be revealed by the long discipline of cumulative data and the steady refinement of method. That is less cinematic, but, ultimately, truer to what the planet can teach, that history is written in subtle traces, and that the noblest human response to deep time is a mixture of curiosity, restraint, and reverence. What would a vanished technology look like after the slow, indifferent erasure of millennia? That question sits at the center of a different kind of thought experiment, one that asks not merely whether life persisted beneath a warmer Antarctic sky, but whether societies once learned to bend matter in ways that modern instruments might still, somehow, detect. It asks whether humans or human-like collectives could have developed industry, metallurgy, or even proto-electronics, and then, by climate, contagion, or conflict, been folded into the same geological ledger that buries forests and rivers. The proposition is unnerving because it collapses two temporal registers, the intimate time of social life and the vast time of geology. The same forces that make Antarctica an archive also make it an eraser. The possible routes to cultural disappearance are familiar in outline: climate collapse, pandemic collapse, and violent collapse. But their consequences, when tens or hundreds of thousands of years are allowed to pass, are subtle and counterintuitive. A prolonged warming can flood coasts and drown cities. A glacial advance can bury them. A pandemic can depopulate a region, leaving infrastructures to decay or be cannibalized by survivors. War can flatten and burn, but it can also disperse materials and contaminate sediments. Each mechanism leaves a different profile in the Earth's memory, and whether anything survives depends less on drama than on chemistry, depositional context, and the caprices of diagenesis. Take climate change as a mechanism of both disappearance and preservation. A century of anthropogenic warming is already writing a distinctive isotopic line in the atmospheric record, an excursion in carbon isotopes that future geologists would read as an abrupt perturbation of the carbon cycle. If an earlier civilization rose and fell in an interval of dramatic greenhouse gas fluctuation, its industrial activity might likewise leave a pulse, a concentrated deposition of combustion byproducts, soot horizons, an anomalous spike of black carbon in peats and coals, traces of combustion-derived polycyclic aromatic hydrocarbons. Under the right burial conditions, rapid sedimentation in an anoxic basin or swift encasement beneath glacial till, such chemical signatures could be preserved for very long stretches of time. But the details matter. Many industrial markers are chemically labile. Plastics, for example, while notorious for their persistence on human timescales, are subject to hydrolysis, photodegradation, and microbial breakdown over geological epochs. Certain synthetic polymers might leave recognizable backbones altered into molecular shards, others might be transformed into a suite of smaller organic molecules indistinguishable from natural geochemical products. The same applies to metals, iron rusts and migrates, copper leaches, alloys diffuse, concentrating in unexpected strata. The durable signatures are often the unexpected ones, anomalous ratios of platinum group elements, odd concentrations of palladium or rhenium, or persistent isotopic anomalies that stand out against natural baselines. Pandemics, as a route to cultural collapse, are psychologically more intimate and socially more diffuse. A pathogenic wave that removes a large fraction of a population can halt maintenance regimes, dikes will not be repaired, irrigation channels will silt, and power systems will feed off themselves until they decay. The material footprints that survive are those that are either inert and robust, ceramic vessels vitrified by fire, stone foundations, or those that alter their chemical surroundings, industrial slag, concentrated metal smelting residues, and unique mineral assemblages created by sustained high-temperature processes. Whether human response includes flight to refugia or the abandonment of sites, organic matter may be left to the elements, and many of the finer cultural artifacts, textiles, wood, unburned organics, will simply decay or be consumed by geological processes. Only in the most exceptional preservational contexts, sudden burial in muds, entombment in peat, or isolation beneath cold, stable ice, do fragile traces persist. War, perhaps more than either climate or disease, leaves a paradoxical record. On one hand, conflict is destructive. It pulverizes architecture and scatters populations. On the other, the industrial logic of war concentrates certain materials, denser stores of metals, concentrated emissions of combustion and explosives residues, and, in the nuclear era, radiogenic signatures. Nuclear isotopes are an instructive example of how certain traces can outlast civilizations. Some isotopes decay too fast to be useful across millions of years, but others and their daughter products can be indicators for deep-time inquiry. The survivability of such isotopes depends on half-lives and on geochemical mobility. Even then, diagenetic reworking can redistribute them. In short, warfare can seed a landscape with detectable anomalies, but over geological time, those anomalies are filtered, blurred, and, in some cases, erased. Antarctica's role in this calculus is distinctive. The continent is an accidental vault. It did not intend to archive humanity, but its physical processes, burial under ice, isolation in subglacial basins, a noxic sealing of sediments create contexts in which otherwise ephemeral signatures can be preserved. A peat layer trapped beneath a glacier is, in effect, a time capsule. A subglacial lake sealed off from oxygen for millions of years functions like a cold repository where organics might decay very slowly, where lipids and certain polymer fragments can persist in altered forms, and where geochemical anomalies can be isolated from the mixing and weathering that characterize most continental shelves. The mechanics are important. Glacial burial can rapidly lower oxygen exposure and microbial activity, thereby slowing rates of organic breakdown. Fine-grained sediments, silts, and clays compact and exclude fluids, immobilizing particles and, if chemically reduced, preventing metal mobility. In such settings, even volatile molecules can be trapped, incorporated into mineral matrices, or bound to organics that later skeletize into kerogen. The iron and sulfur cycles in reduced sediments can precipitate sulfides that sequester trace elements, preserving concentrations that would otherwise be mobile. The net effect is that Antarctica, by burying and isolating, sometimes preserves what would be lost elsewhere. But preservation in the cold vault is not an unambiguous benevolence. Ice flow deforms strata over time. Pressure, heat from bedrock, and basal melting at contact zones can cause metamorphism. Periglacial processes can sort and concentrate materials unpredictably. Preservation is therefore selective. Some chemical classes make it through, others do not. The continental archive favors certain signals, robust molecular fossils, isotopic excursions, certain trace metal enrichments, while it erases the ephemeral signals of form and texture. Stone foundations, for example, may be crushed and dispersed. Pottery shards may be abraded beyond recognition. The archive is less a museum of artifacts and more a ledger of processes. What would a technological signature surviving in Antarctic strata actually be like? It is worth listing the plausible candidates and their detectability. First, isotopic excursions in carbon and sulfur that do not correspond to known volcanic or climatic drivers. A spike in 13C coupled with a layer rich in black carbon could suggest widespread combustion. Second, concentrations of uncommon transition metals, nickel, chromium, platinum group elements, in a discrete stratigraphic horizon, uncorrelated with known ore layers, could indicate smelting or industrial catalysis. Third, molecular fossils, long-chain hydrocarbons with branching patterns inconsistent with biological origins, or persistent halogenated compounds whose stereochemistry does not match natural biosynthetic pathways. Fourth, anthropogenic radionuclide fingerprints. While many anthropogenic isotopes would decay away in the deep future, some daughter-product ratios might still be anomalous relative to background and thus infer a past episode of fission or transmutation. Lastly, morphological sediment anomalies, compact horizons of slag-like deposits, glassy melt layers could point to sustained high-temperature processes. Aye, those are the traces scientists would look for, and Antarctica's buried basins are among the few places where such traces might survive a very long time. The irony is sharp. The same process that made the continent a seeming void also made it an accidental preservatory of the things that humans might most like to keep: chemical echoes, not statues; isotopes, not inscriptions. All of this reframes the ethical and emotional dilemma. If the continent is a vault, does humanity have the right to open it? There is an immediate practical calculus. Some of the most promising archives lie beneath kilometers of ice or under delicate, isolated ecosystems. Drilling to access them requires technologies that can introduce contaminants, microbes from modern laboratories, drilling fluids, heat, and that can irreversibly alter the sites. The Antarctic Treaty and associated protocols already require careful environmental assessment for scientific projects, but the moral weight of those assessments becomes heavier when the commodity of interest is not just knowledge but the possibility of reviving ancient organisms or uncovering chemical signatures that reframe human origins. Curiosity pulls one way, stewardship pulls another. The scientific urge to sample is powerful. Each core is a potential key to a chapter otherwise lost. But the precautionary principle demands containment, staged access, and international oversight. If an ancient microbe were revived or a chemical anomaly discovered that suggested sophisticated past technologies, the consequences would ripple beyond academia: biosecurity concerns, geopolitical jockeying for access and claims, and the cultural shock of having very long human timelines rewritten. Decisions about disclosure would not be technical alone, they would be political and ethical. There are also pragmatic constraints on the willingness to open vaults. The effort required is immense, logistically demanding, expensive, and environmentally risky. The tourist and commercial pressures that accompany spectacular finds complicate matters further. Melting ice due to modern warming will expose more of the record, but exposure is not the same as preservation. Thawing peat oxidizes quickly, releasing carbon and obliterating the very signatures that might have been studied. Warming may create a narrow window in which to act responsibly. It may also force hurried interventions that prioritize immediate access over careful science. Finally, the cultural dimension is salient. The notion that entire civilizations might be entombed in a remote white continent confronts deep-seated human narratives about continuity and centrality. The idea threatens mythic assumptions about being first and unique. That emotional charge explains, in part, why the possibility is so compelling, and why it has been injected into popular myths for generations. But the scientific posture must resist the seduction of narrative closure. Extraordinary claims require extraordinary provenance, multiple independent lines of corroboration, careful stratigraphic control, and replication across laboratories. The calculus of daring is therefore multi-layered. To attempt retrieval responsibly demands robust criteria: clear, convergent geophysical signals suggesting preserved sediments, demonstrable anoxic burial conditions conducive to preservation, minimal ecological intrusion, internationally agreed sterilization and containment protocols, phased access with transparent peer review, and an ethical framework that coordinates disclosure with biosecurity and cultural sensitivity. Absent those scaffolds, the act of opening risks more than discovery. It risks contamination, geopolitically fraught claims, and the irreversible loss of context that would inform any interpretation. Thus, the White Continent becomes a test not merely of scientific curiosity, but of civic maturity. Would humanity, offered the possibility of pulling back a curtain on a deep past, choose reckless exhibition or patient guardianship? The answer is not obvious. It depends on governance structures, public culture, and the distribution of power. The debate will likely be noisy and morally fraught when the first compelling anomaly arrives. Some will call for immediate sampling in the spirit of discovery, while others will insist on delay, sterilization, an international deliberation. The real drama is not cinematic. It is procedural and ethical. It will play out in committees, in laboratories running blind replication studies, in international treaties, and in the slow, meticulous work of cross-validating radar with gravity, magnetics with cores, molecular fingerprints with isotopic baselines. The continent's archives do not yield to spectacle. They surrender evidence in small increments, a consistent isotopic anomaly here, a trace metal cluster there, a reproducible molecular oddity in a sealed horizon. Each increment must survive the scrutiny of independent replication, of cross-disciplinary interrogation. Only then does an extraordinary hypothesis transform into a credible revision of history. In the long horizon of the story, the question that follows all the technicalities and ethical choreography is simpler and sharper. Will humanity dare to drill, to sample, to possibly unseal biological and chemical legacies that could change understanding and carry risks? Dare to accept the responsibility that accompanies any recovery of deep-time records? The white continent is both repository and mirror. It stores the planet's ancient pages and reflects back how the present-day species chooses to handle knowledge. That choice, the narrator suggests, will reveal as much about contemporary civilization as any recovered artifact might reveal. About an ancient one, the next part will press on that hinge. It will consider the practical rules and moral frameworks that might govern access. Who decides, by what criteria, and with what assurances? For now, the question remains poised at the lip of the vault. The ice keeps its counsel, and humanity must decide whether and how to listen without breaking what it seeks to understand. Part 11. At the final threshold, an idea stands in the doorway like a candle. What if the last door beneath the ice opens not onto artifacts and triumphal proof, but onto something that forces humanity to change the story it tells about itself? What if the problem at the final threshold is not a lack of technology, but a lack of moral vocabulary, a hesitation born of fear, of belief, and of the capacity to accept a history that does not center the present human species as the sole subject? The image is not cinematic. It is domestic and terrible, a planet that has long kept multiple scripts, chemical, geometric, isotopic, and now, perhaps, begins to press one new, difficult line into the margin of human knowledge. This is the question that shapes the 11th part. Mio, the recognition that what lies behind the last lock is not merely physical evidence, but a demand to reconsider the categories by which humanity counts itself. Could Earth once have hosted multiple humans, not merely our own lineage, but other intelligent, social beings whose traces would look different, whose legacy might have been written in molecules rather than monuments? The proposition unsettles because it undermines several quietly held assumptions. That human history is continuous and legible in stones and texts, that intelligence leaves the same kinds of durable signatures. That current archaeology expects, and that scientific discovery will be purely technical, its ethical dimension secondary. The doorway widens when one attends to the language of definition. Human is at once a biological term grounded in taxonomy and an ethical category that carries rights, obligations, and meaning. Scientists, historians, and philosophers have long argued over where to place the line between Homo sapiens and other hominins, and how to judge cognitive capacity from bones and tools. But the deeper thought experiment here is not merely taxonomic, it is about the plurality of intelligence. An intelligence may build durable material culture, or may leave its mark in altered biogeochemical cycles and concentrated element ratios. It may create symbols carved in stone, or it may develop economies of scale that pump particular isotopes into sediments. The evidence that survives in 1,000,000 years is rarely sculpture, it is chemistry, geometry, and anomalies that admit of multiple explanations. That reality reframes the ethics of discovery. The instruments that now scan for echoes, radar, gravimetry, isotopic mass spectrometers, are blunt instruments for questions of meaning. They can detect an anomalous platinum group concentration as easily as they can a folded stone wall. The first task, then, becomes epistemic. How to recognize intelligence in a record that prefers molecules to monuments. The answer cannot be purely methodological. It is also procedural and political. It demands standards of proof that are appropriately stringent, transparent chain of custody procedures, an international architecture for verification, an inclusive deliberation that reaches beyond disciplinary silos. The burden of proof is a moral as well as scientific requirement. Extraordinary claims that would expand the definition of what counts as human or as a technological actor on this planet, require not only extraordinary evidence but extraordinary processes of validation. That means multiple, independent lines of corroboration, geophysical signatures that align with sedimentary contexts, chemical and isotopic anomalies reproducible across laboratories, molecular markers that cannot be traced to contamination, and stratigraphic controls that confine anomalies to discrete, datable horizons. It also means resisting the temptation to let a single, suggestive dataset become a headline. Science in this domain must practice an almost monastic prudence, publish methods, share raw data, and invite global expertise to replicate findings before grand narratives are built. But the threshold problem is broader than evidence. It admits a social amphitheater where belief and identity will quickly gather. The cultural stakes are high because narratives of human uniqueness are bound up with religion, with national mythologies, and with the moral frameworks that govern entitlements. If the planet produces incontrovertible signs that human-like intelligence, organized societies, or industrial-scale processes once existed in a different configuration of time, the immediate reactions will not be neutral. There will be wonder, certainly, a delighted revision of the cosmic timetable. There will also be resistance, denialist reflexes that insist on the primacy of current accounts, conspiracy theorists who claim suppression, and political actors who see advantage in controlling the story. Religious and philosophical communities will face urgent interpretive labor. The discovery that intelligence arose on Earth in more than one form will be read through many hermeneutic lenses. Some traditions may integrate the finding with existing cosmologies, enriching narratives of creation and stewardship. Others may feel threatened, interpreting the evidence as a challenge to doctrinal claims. Those variations are not merely intellectual, they shape policy. Public authorities will be pressured to act quickly, to release or withhold data, to authorize or block drilling under the manifold weights of curiosity, caution, and claim-making. Indigenous voices deserve explicit mention in any responsible account. Throughout the world, indigenous peoples have long narratives about human origins and relationships to land that are not reducible to scientific hypothesis. Those narratives are often sidelined when new discoveries press into global headlines. The ethical response requires procedural justice. Consultations with communities that claim cultural relationships to polar regions, direct or symbolic, inclusion of diverse perspectives in interpretive committees, and critical care not to reproduce histories that erase or instrumentalize other people's memories. If a deepest past were to be revealed, the conversation about meaning must be global, plural, and attentive to forms of knowledge beyond academic science. Practical governance is the next hinge. The Antarctic Treaty System provides a partial template, an international framework that privileges scientific cooperation, bans national appropriation, and mandates environmental protection. But it was not designed to adjudicate questions about newly discovered ancient civilizations, about the moral status of ancient remains, or about global disclosure of information that may have security implications. A discovered anomaly that hints at multiple human-like actors will therefore require new governance architecture. Several principles suggest themselves. First, a moratorium on invasive sampling until the multinational scientific ethical committee can evaluate the risks. Second, mandatory open data protocols for non-sensitive geophysical datasets. Third, a transparent chain of custody for samples with independent replication of analytic results. And fourth, an international advisory body composed not only of geologists and chemists, but of ethicists, legal scholars, representatives of indigenous groups, and public communicators. Biosecurity complicates the picture in personal and urgent ways. Even the possibility that revived microorganisms might carry unfamiliar metabolic pathways or genes changes containment protocols, from best practice to moral imperative. The same containment logic that governs contemporary research into novel pathogens applies here. Secure laboratories, stepwise disclosure of genomic data, and an international mechanism to assess biological risk before materials are moved or published in full. If the threshold of discovery includes a novel organism, an ancient metabolism that resists classification, then the world will need an ethical architecture similar to the international health regulations, rules and obligations that limit unilateral action and require coordinated, transparent response. There is a parallel legal question about ownership and stewardship. Who holds the samples? Governments that financed expeditions may claim custody. Scientific institutions may assert intellectual property rights over data. Indigenous groups may claim moral rights of consultation. International law has little precedent for such a case, especially when evidence suggests a deep time passed with no living cultural descendant. The prudent and equitable solution will be procedural, an internationally agreed trust or repository model that ensures materials are accessible for verified study while guarded under strict containment and stewardship rules, a global public commons rather than a national prize. The cultural consequences of an accepted discovery must be anticipated, if only to manage harm. The temptation to turn the finding into spectacle, tourism, commercialization, and geopolitical signaling will be strong. The same media dynamics that turn every fragment into a headline today will operate on an amplified stage when discovery grows. Beyond the laboratory, that dynamic argues for a communication strategy grounded in humility, clearly distinguishing provisional results from robust conclusions, explaining uncertainty, and taking responsibility for the social cascades triggered by premature claims. Scientists and institutions must learn to be slow when the public demands immediacy. They must accept that the moral price of speed can be profound misinterpretation and social destabilization. Yet not all consequences are negative. If the world can approach evidence with patience and care, discovery invites a deeper ethical transformation. The acknowledgement of a plurality of long-buried beings reframes the human project. It dissolves anthropocentric narratives of inevitability and replaces them with a humbling view. Intelligence can arise in many forms, flourish for a while, and vanish without leaving the kinds of monuments modernity prizes. That humbling can give rise to an ethic of stewardship, a commitment to protect fragile archives, to treat even ancient remains with respect, and to redesign education so that future generations inherit a more complex, less triumphalist history. There are rhetorical traps in this terrain that the documentary voice must name. The first is the seduction of narrative closure. A single, striking anomaly can be wrongly made to stand for a whole epical claim. The second is the impulse to turn discovery into a claim of precedence, of being first to perceive a truth. Both tendencies are corrosive to the slow, collective labor of verification. The antidote is institutionalized humility, cross-validation, open repositories of raw data, pre-registered replication protocols, and a global governance ethos that privileges shared stewardship over proprietorial success. Designing institutions to steward discovery at the final door is a technical challenge and a moral one. One feasible architecture is a staged authorization model. Stage 1. Remote sensing and non-invasive surveys with mandatory open data release within agreed confidentiality bounds. Stage 2. Independent, multi-lab confirmation of anomalous chemical or isotopic results from peripheral cores published with methods and raw data. Stage 3. Convening an international, multidisciplinary panel to weigh evidence and to create an ethical and legal plan for any invasive sampling. Stage 4. Only then, and under strict sterilization and containment protocols and international oversight, might more intrusive sampling occur. This is not an arbitrary bureaucratic delay, it is a moral firewall designed to protect ecosystems, to preserve context, and to prevent the kind of unilateral actions that can create irrecoverable harm. Such committees would need legal teeth. Agreements under the Antarctic Treaty could be expanded or supplemented by a new protocol that stipulates sample custody, data sharing obligations, and sanctions for concealment or irresponsible disclosure. The World Health Organization's governance around biological threats could inform biosecurity protocols for ancient microbes. UNESCO's conventions on world heritage and intangible cultural heritage offer models for inclusive consultation when human-like artifacts are involved. The point is procedural pluralism. No single international body holds all the levers, but a coordinated suite of institutions can ensure that discovery is framed as a global commons rather than a national trophy. Finally, the threshold challenges a psychological readiness that is less institutional than cultural. Humans are story-making creatures. They want continuity, explanation, a thread to stitch present to past. Confronted with the possibility of multiple intelligences in deep time, many will experience cognitive dissonance. Some will accept the evidence readily, others will resist. The social task is to create rituals of collective coming to terms, educational programs that incorporate uncertainty, public fora that allow plural interpretive voices, and a media ecology that rewards careful reporting over sensationalism. This is not merely polite democratic practice. It is the only reliable way to avoid the political exploitation of discovery and the attendant harms, the weaponizing of history for territorial claims, the commercialization of fragile sites, the polarization of public belief. On the other side of the threshold sits a quieter obligation to reorient the language of consequence. If Earth once hosted other intelligences whose traces are chemical and isotopic rather than monumental, humanity's first ethical demand is not triumphalism but humility. The preservation of the planet's deep archives is an act of intergenerational justice. It is an admission that knowledge does not belong to any single moment. Stewardship is not merely a professional duty of scientists, it is an ethical covenant that binds present beings to future readers of the sedimentary script. The final threshold is therefore less about mechanics and more about character. The instruments are capable, in principle, of reading what the planet has written in its slow ink. The legal mechanisms can be built or adapted. The ethical frameworks can be drafted. The harder work is cultural, cultivating a public and institutional temperament that prizes patient rigor, that honors plural interpretive communities, and that resists the easy pleasures of immediate narrative closure. The image at the end is paradoxical and simple. The world stands before a heavy, sealed door in the ice. Behind it are pages of the planet's biography, some mundane, some strange, and some possibly threatening of long-held assumptions. Humanity has the capacity to slip inside and read. It also has the capacity to do harm in the act of reading, choosing how to act, whether to pry and publish immediately, to lock and wait, or to convene a slow, inclusive process of verification and stewardship will be itself a revelation about the species that has come to ask questions. Of the deep past, the test at this last door is not of curiosity alone, it is of moral imagination. The willingness to accept a history that might be stranger and more plural than any national myth will comfortably allow, and the readiness to govern that revelation with restraint, transparency, and an ethic that honors both life and the long memory of the planet. What if the final act of the planet's long forgetting is not a revelation, but a paradox, a moment when the thaw that promises to show the past also consumes the very evidence it might reveal? The question sits like a glass of cold water on a table, simple to place, difficult to drink. It reframes everything that has come before. For decades, scientists have read Antarctica as a conservatory of deep time, a slow, indifferent archive that preserves pollen, isotopes, and chemical traces in a ledger of ice and sediment. Now, that conservatory is opening its windows under the pressure of a warming world. The edges of the metaphor begin to blur. Melting ice is both an unlocking mechanism and an eraser. As the ice recedes, what will actually appear? And the harder question, is humanity ready for what that appearance will demand? The physical mechanics are unromantic and immediate. Ice sheets do not vanish in a single cinematic sweep. They retreat, fracture, thin, and expose. As they do, landscapes that have been isolated for millennia are suddenly exposed to oxygen, sunlight, and biotic colonizers. Organic matter that slept in anoxic solitude begins, within days and years, to oxidize and decay, peats darkened by time-released carbon in bursts. Lipid biomarkers, once locked in cold matrices, oxidize and break into chemical fragments that may no longer carry the signatures of their origin. The same processes that once preserved molecular fingerprints now, in the act of thaw, accelerate their dissolution. A sedimentary horizon that might have told a story of anomalies, a spike of unusual metals, an isotopic excursion, a concentration of combustion residues, can be altered irreversibly simply by exposure to air and running water. The window of accessibility is narrow and perilous. To see is sometimes to unmake. There is technical immediacy to that peril. When a core is retrieved from beneath ice in controlled conditions, it offers a carefully contextualized sample, stratigraphy intact, chemistry relatively unaltered, dates bracketed. When the same layer is exposed, by retreating ice and left to weather, that contextual information dissolves. Erosion sorts particles, water flushes soluble ions, microbial communities that have been dormant bloom and consume. The material testimony of epochs becomes a palimpsest of modern processes. In other words, climate-driven exposure can produce two opposing outcomes at once. It can permit study by making sites reachable, and it can destroy the sane potential evidence through the chemistry of thaw. The contradiction has an ethical edge. The thaw creates a triage problem. Some sites are moments of opportunity that require immediate, careful intervention. Many are not. Deciding which pages of the planet's archive to pry open demands more than curiosity. It demands criteria, protocols, and a humility about consequences. The theorems of preservation and destruction thus turn into policy questions. Which messages from deep time should be read immediately in controlled conditions? which should be left unexposed and studied only by remote, non-invasive methods. Who decides? Under whose authority will a drill be deployed? These are not hypothetical bureaucratic matters. They are the moral architecture of the next century of polar science. The kinds of discoveries that could be revealed by melting are the same classes that have been the focus of disciplined inquiry. For years, chemical anomalies, isotopic excursions, molecular fossils, and geometric echoes in bedrock geometry. What melts will not always be literal ruins, not pristine cities trapped mid-step, but rather traces, a narrow stratigraphic horizon enriched in rare metals, a pulse of synthetic-looking molecules preserved in a sealed peat, an isotopic signature of intense combustion inconsistent with known volcanic events, a radar reflector that aligns with a sedimentary basin hosting unexpected concentrations of organics. These are the durable signals that can survive deep time and that might come into view as the ice retreats. There are also the biological possibilities, microbial communities currently sealed in subglacial lakes and sediments. Waking such life forms carries both scientific promise and ethical peril. On the one hand, microbes adapted to dark, cold, high-pressure chemistries could rewrite understanding of metabolic flexibility. They could inform astrobiology and broaden notions of habitability. On the other hand, reviving long isolated life raises biosecurity questions that cannot be blithely postponed. Unknown metabolisms could alter local biogeochemistry, and the transfer of ancient genes into modern communities is a plausible risk whenever containment fails. The precautionary principle is not a mere bureaucratic posture here. It is a guide to preventing irreversible ecological mistakes. The social and political stakes multiply quickly. The Antarctic Treaty offers a common framework: cooperation, environmental protection, and a ban on national appropriation. But it was never designed to adjudicate the discovery of things that might fundamentally alter human self-understanding. If a sediment horizon were to show clear, reproducible evidence of industrial-scale metallurgy tens of thousands of years ago, the ripples would go beyond scholarship. Claims would be made of priority, of proprietary access to samples, of national stewardship. The temptation to treat any dramatic hint as a geopolitical advantage is not hypothetical. It is the predictable logic of states facing valuable, ambiguous assets. That is why international governance must be anticipatory rather than reactive. The pragmatic architecture needed is straightforward in principle and complex in practice. It requires staged intervention, non-invasive reconnaissance first, combining radar, gravity, and magnetics to build a robust geometric and physical model, targeted shallow coring next, precisely to retrieve contextualized sediments under sterile conditions, and only then deeper sampling if multiple. Independent mines of geochemical evidence point to something exceptional. Every step must be governed by a transparent chain of custody, open data sharing of non-sensitive geophysical datasets, and an international oversight mechanism that includes not only scientists but ethicists, legal experts, and representatives of diverse cultural communities. In other words, the act of reading the planet cannot be a unilateral or secretive enterprise. It must be collective and accountable. Biosecurity protocols deserve explicit emphasis. When potentially viable organisms are involved, containment is non-negotiable. That means high containment laboratories, standardized sterilization procedures for coring equipment, international protocols for sample transport, and a staged release of genomic and geochemical data only after independent replication under secure conditions. The logic is simple. Scientific openness is essential for credibility, but it must be balanced against the duty to prevent accidental harm. A model similar to international public health mechanisms, where potentially dangerous samples are treated as global public goods that require secure handling, could inform policy. There is also an urgent need for a cultural shift in public communication. The present media environment privileges spectacle. Images of straight lines beneath ice or evocative fragments unearthed in a thawed peat are prone to instant myth-making. Sensational narratives will circulate faster than careful science. The scientific community must therefore commit to disciplined, clear communication that explains uncertainty, stages findings according to their robustness, and resists the temptation to convert possibility into proclamation. The public, in turn, must be given tools to understand what convergent evidence looks like: multiple independent datasets, reproducible chemical signatures, and peer-reviewed synthesis. Building that literacy is a civic responsibility. Ethics, however, cannot be reduced to procedures. At a deeper level, the thaw forces a collective moral question about human responsibilities toward the non-human past. If Antarctica houses fragments of ecologies and possible artifacts beyond current comprehension, the choices made now are not solely about discovery. They are acts of caretaking or desecration. To drill without adequate sterilization risks not only contamination, but the destruction of irreplaceable context. To leave a site unexamined may feel like an abdication of curiosity, but it may also be the most respectful decision in some cases. The rightness of action depends on humility, on a sober accounting of what is at stake, and on a commitment to proceed only when the benefits for knowledge outweigh the risks. To ecosystems and archival integrity, this humility extends to the interpretive frameworks that will be used to read any finds. The human urge to build narrative continuity is powerful. The desire to fit a fragment into a grand story about origins, migration, or lost civilizations can lead to overreach. Deep time archives do not offer narratives in human form, they offer probabilistic patterns. A cluster of metals could be industrial residue, an unusual ore deposit, or the result of diagenetic concentration. A molecular oddity could be a novel metabolism or a laboratory contaminant. The standards of evidence must therefore be high, convergent datasets, independent replications, and rigorous stratigraphic control. Extraordinary reframings of human history must rest upon extraordinary convergence. There is, finally, a moral question about preparedness. Are institutions, citizens, and international bodies ready to handle discoveries that will challenge cherished narratives? Readiness is not merely technical, it is cultural and legal. It requires robust institutions that can withstand political pressure, clear legal channels from multinational stewardship, ethical training for scientists operating in exceptional contexts, and public education that fosters patience and curiosity without succumbing to sensationalism. The alternative is dangerous. Ad hoc decisions driven by national interest, commercial exploitation, and the fever of viral headlines. Melting will not be a single revelation, but a cascade of micro-choices and small discoveries. Some will be methodical and credible, others will be ambiguous and contested. Some exposures will be opportunities for careful, collaborative science that illuminates ancient ecologies and deepens understanding of life's resilience. Others will be moments of loss where priceless chemical records oxidize within seasons. The duality is cruel. The same warming that affords access also obliterates context. The task, then, is to build systems that convert the moment of exposure into a disciplined, ethical act of reading rather than an act of plunder. The closing image is austere, a thin, irregular line of coastline revealed where once there was only ice, a slice of peat black. With age, crumbling into a rivulet that carries fragments of ancient chemistry into the sea, a radar reflector traced into a map, and flanked with caution. Around these sites assemble scientists in clean suits and panels of international advisors, journalists whose questions demand clarity and restraint, legal experts translating treaty language into operational protocols. The scene is not cinematic, it is procedural. It is the choreography of care. The largest question remains not technical but moral. When the last ice finally withdraws, will the truth that emerges be welcomed as something to steward gently or seized as spoils and spectacle? Will the species that learned to harness fire and metal also learn to wield restraint? For the planet's long whisper to be heard and understood, humanity must match curiosity with humility, speed with care, and the desire to know with the duty to protect. Only then will the thaw be more than a reveal. It will be a reckoning of responsibility, an answer to whether this era of discovery can be governed by wisdom rather than by appetite. The ice will not wait for moral clarity. It will melt according to the physics of heat and albedo. What will be left is the record of choices made in the near term. Who was allowed to read? Who stood aside? What was lost because eyes came too late or because protocols were absent? The question that hangs finally is simple and sharp. When the white continent hands the planet another page, will humanity be ready to read it in a way that honors both the truth revealed and the life it may yet disturb? The answer will be written not in radar echoes or in isotopic ratios, but in the policies, institutions, and ethical practices that are forged now, while the ice still yields the possibility of careful listening.